All right. What are we doing? I need to open up all the web pages for all the stuff we're working on. Oh boy. God, what a week it's been. What a week. Tried to clean up a little bit in here. This was the day before yesterday. What did I do yesterday? Oh yeah, I figured out what the rest of the circuit would be on how we're gonna go about making the keyboard work. So if at all possible, I'd like to make a ton of progress today. And I did all the IDE stuff. I got to compile the first, well, what was in the tutorial I got to compile, but I didn't get anything working yet. Waiting for you guys to do that. So we're gonna work on that. Got a lot of remapping to do because I decided to use muxes. Muxes are fun. So this needs to be a little louder, doesn't it? Oop, that wasn't loud at all. A little over 50%. That should give it a little bit of, I don't have a final mix in my ears, so I don't know. I don't know where I clock in volume-wise. Oh, we need to pare down some of these. Holy crap. Gone. Gone. Yeah, we're not doing I2C. These are the Max 308. Kind of an old chip. I don't know what the dwell times are on this thing, or whether or not our switching time is going to be affected. What's better than bad code? Documented bad code? We're not using this. Okay, we're good on that one. Yeah, I gotta move the windows. I gotta do this, because then my thumbnail is gonna be terrible if I do that. Boy, oh boy, it's been a trip. I've been playing with a puppy basically during all of my off time from stream to try to keep people here from going absolutely psycho at the sudden change in their entire existence. It's a big change having a puppy around. She's a sweetheart though. She's very, very cute, but she does bite a lot. She's a herding breed. Got a herd. See, what's gonna happen is my glucose level is gonna take a turn here, and then I'm gonna have to poop. I'm gonna have to poop in the middle of the stream. I had 2 cups of coffee too, and those are burning a hole through my track. Two cups of regular coffee, not even iced. Yeah, we're slumming it today. We're slumming it today because they're doing work on the kitchen. Now, here's a thought. If we get this together with the multiplexers and this stuff over here, these multiplexers, what they're designed to do is you basically give it a binary number and it flips between all of the inputs. This COM A and COM B, I think I have some Max 309s. That would mean, I think the same number of pins, the same number of I/O, because we only have 2 address lines now. And it's 4 and 4, but it's 2 COM ports. So if I need to speed things up, I could read from 2 rows at once. Is that a thing? Would that be a problem if I read from 2 rows at once? What's up, Jeffson? How you doing? Oh, damn it. I should have done 2 messages instead of 1. Some of the windows are 2 messages. Ones like this one are, nope, they're 2 messages. Yeah, I should do 2 messages from now on. I did 2 messages the other day, and they apparently didn't boil into this. Am I running? Oh, I'm not even running Chatterino. Ba-ba-da-ba-ba-ba-ba-ba. Oh, yeah, I am. There it is. Login expired for user. Try adding your account again. Oh, great. Does this one have a chat? This one might have a chat window. No, this one doesn't have a chat window. Okay, let's do this. I gotta do. Disconnected. How do you reissue the account in this thing? I just need to re-add my entire thing. Authorize. And then you guys can't see anything. Copy the authorization. Paste login info. There we go. Close that window and never show anybody it. All right, that should do for Chatterino. I got a whole bunch of, let me just clear the messages. Once. Tuned. There we go. Now it's all primed and ready. Now chat will show up. Anyway, how's it going, Jeffson? Yeah. So I'm looking at this stuff. We're gonna use a muxer in order to provide us with all the stuff, all the rows and the columns that we need to look at. I'm doing good. I'm a little tired. I've been sleeping okay. It's just I had to stay up late last night because my body wasn't responding to insulin the way I wanted it to, and I injected a lot, so I was waiting for it to kind of peak before I went to bed, and that led me to 3 a.m. So I'm a little tired. I'll be okay though, and we've got a significant amount of work that we need to get through today. We're doing muxing. Let me open up my my schematic. Actually, we should open that in Paint because I might want to make edits. My stomach is grumbling. I don't know. I'm gonna have to run in the middle of stream probably for high priority biological processes. So I mapped out all the rows and columns of the keyboard, and then I mapped them out on a grid. So one of the tricks that we're going to be doing, see if I can get a highlighter here, is that these three can move over into the blank space here. So we can double up some of the rows. I don't know if that's going to cause ghosting, but this whole keyboard has diodes on it, so I think that should be okay. Because yeah, it's just simply like this. It's all the rows are connected to one side of the switch, and then the columns are all connected with a diode. Oh, there's another grumble. Oh, the music isn't too loud. I'll turn it down a little. We'll keep it like there. I do want it to be in the background. I don't want it to overpower me. Not everybody likes your music, you know? So I figure the two column engines are gonna run off of the same timing if I, well, with an enable pin. If I want to, I could possibly double the speed of the reads by doubling up on the pins. We have plenty of pins to deal with now that I've done the, you know, now that we have one digital pin reading all of the columns. Any other electronics to this? There probably are. There's probably part of the circuit that I haven't figured out yet, like a pull down resistor or something like that in that circuit. Let's just look up a keyboard matrix circuit. Yeah, see, this one has the pull downs and the resistors on the way to the pin. I didn't observe any resistors on the way to the pin. But I don't know if there's gonna be like any pull-ups or anything like that going on. I don't think so. And basically what you want to do is energize the row and then read the column. And the diodes keep your other rows from communicating. No. But thank you. Thank you, no thank you. We just have a lot of work to do today, so that's why I'm kind of doing this right now. Yeah, here are pull-ups on these, which may or may not exist on this thing. I haven't reverse engineered it completely 100%. There's a lot of stuff to the circuit board, you know? And there could be a 10K ohm resistor hiding. What is that? What is a keyboard matrix circuit? What? Yeah, see, no pull-ups there. They just use the microcontroller pins to let it go high and low. Those are all pulled up. What the hell are you doing over there? They're all pulled up. You get the circuit going up and over. That's 5 volts. 5 volts there, down there. God, somebody is playing with a sliding door, and it's getting on my nerves. This is a cursed circuit. What the hell? Because you got 5 volts there and you got 5 volts there. What are you doing? Doesn't make any sense. What is this? This is like a 1992 webpage. It's a nice clean. I like what they're putting their schematics on. It's nice and clean. It's what I like mine to look like. But 13.1 or no, 10 kilo ohm. 10 kilo ohm. So 10K, 10K. They're all going to 5 volts. So right now they would be held at 5 volts. So you'd be getting 5, 5, 5, 5, 5, 5, 5, 5, 5, 5. But if you press the button, they're still being held at 5 volts. They're both still being held at 5 volts. Only you've got a 5 kilo ohm resistor in there. Is that what they're measuring current or something? Oh, well, no. Row and column make contact, but they're at 5 volts. This doesn't make any sense. The circuit doesn't work. Unless there's some radical thing that I have not yet considered. Like, for instance, if you set the row to 0, you're pulling through the 10K ohm resistor of the row, and you're making that 0, and then if you push the button, I guess you'd be driving the column to 0 as well. So if you put a 0 there, you get a 0 there. I guess that makes a little bit more sense, because you'd energize the rows, and then they'd be held high when they're not activated. Might actually be the scheme that we need to use. Might actually be the scheme we need to use. And there's software. Okay. All right. Well, that's what that one is. That was weird. That took me a little bit to figure out because of the switch in positive and negative. Yeah, the diodes are there to keep you from getting like a ghost press. You could press one part of the keyboard and it would look like a different part is actually being activated. Wait, where's my... Well, it's an LED to be powered as well. I guess so. Oh yeah, there it is. I didn't prime the first and second message, I guess. Thought I did. Weird. There it is. Miguel Oz. Oh my God. 29 months. Dude, that's a lot of time. Thank you very much for the 29 months, Miguel Oz. I do genuinely appreciate it. That's a long time to be subbed to the channel. Hope we can keep things fresh around here. I'm just getting going. I'm a little tired today. I was up till 3 a.m. waiting on insulin. And then we've also got this puppy here, which, you know, pictures in the Discord. But man alive, it's a little bit of work. She's a very good puppy though. She's very cool. Very, very cool. Good addition to the family. I don't know how much reverse engineering we need to do with this, but Hello, fellow diabetic, type 1 here. How's it going, man? I just started looping, so I'm working on supply issues with Omnipod pumps. I'm still a little bit on the fence about the Omnipod, but I'm liking it because I'm sleeping better because I don't have something on my belt for once in 20 years. And then I've gone with the third-party applications, so I'm looping, which is amazing. It's actually doing really well. It's sort of it's like the T-Slim, but it's more aggressive about everything, as I told it to be. And then I've also got the records sharing here, where it's totally public knowledge. You can just go to this website and see my progress and why I was up until 3 o'clock in the morning. Jesus, look at all this stuff. Look at all this information. Yeah, I went to bed like around here. You can see my glucose level didn't respond at all. Blech. Yeah, well, with the puppy, having a plastic tube on my belt is probably not a great call, huh? Doo-doo-doo. This is my buddy, Big John, Costa Rican set, very recent, 2014. It's still a pretty banging track, and it gets us. Copyright bots aren't too particular about it. So, where did the page go? What was I looking at? Yeah. Anyway, this is all the records keeping from all my boluses and stuff. The problem is I'm very insulin resistant. Oh yeah, sorry. Yeah, so here are all my records, and it's completely public knowledge. You can just check it out. It's all being uploaded live via my cell phone, and the Omnipod Dash, the slightly older Omnipod, not the latest and greatest. But you can see what's going on, and yeah, I was up until right around here. Oh, it's not doing the predictions right now. I was up until right around here, waiting for insulin to respond because it gave a lot of insulin, and then nothing happened. Yeah, she tended to chew on wires for a little bit. She's very bitey. She's a herding breed, so she's gonna naturally kind of be bitey for a little while. Her teeth are still coming in. I got scars, but she'll be a good pup. Just need to train her a little bit. Yeah, love my pup, but that first year takes a little out of your soul. That's where we are right now, yeah. We're in the throes of that. We're about 1.5 weeks in. Bite her back, that fixes everything. I have been giving her a bop on the nose, but when I give her a bop on the nose, the game is then to bite my hand that bopped her. So then I bop her with the other hand, and then she bites the other hand, and I just go back and forth until she gets frustrated and then either barks at me or starts gnawing on her toy. So she knows what she should be doing. She knows how to be good. She just isn't, which is, it's funny. It's very cute. She'll grow out of it. It's just right now the only way to get her attention is to just do a little tap right on the nose, and she's like, fine. So then the meta became, and I posted pictures of this in the Discord, the meta became to get her toy and then saddle up against my leg like she wanted to cuddle, and just, oh, I'm just here chewing on my toy. I'm not here to bite you. And then she'll just turn her head and just bite me. Pretty sure it's quite a challenge. My pup is 5 now. We got her as a puppy. Really knew how to test this. Yeah, this dog, you can see her go, because she thinks she's a lot smarter than you, and she is smart for a dog, but she's not smarter than you, and so you can tell she knows what she shouldn't be doing, and she's intentionally doing it, which is fun. It's just funny. So we'll get there. It's just gonna be a little bit of time till she knows what she's doing. All in due process. Can you charge for me? Hello? Charger? Cell phone charger? Hello? Her friends were over today. The neighbors have corgis as well, and one of them is even from the same breeder. So he's got a big round face. He's kind of a bigger puppy, but he's got long hair. The name Willow is going to describe the dog very well when she grows up. But yeah, she had her buddies over, and they were just being crazy upstairs. It'll get her tired for the afternoon though, which is good. All right, let's see here. Oh yeah, my schematic. This is our working document. This is everything that we need to know about what we're doing today. We're gonna try to get a bench test set up. I don't know exactly. I mean, we might just jump into the full version. If I need to load QMK onto the Pico Pi and test that, we need to get the hello world done first. See if we can get the display working alone, and then we need to build a board that's going to have all 3 of the shift registers on it. That's the goal for today. Let me just get started. I'm a little less conversation-y because the only thing that I've been doing has been playing with a puppy. What just happened? Somebody did something. Pete Newcomb, thank you for the 14 months. I appreciate that. Saying hello. How are you? How's it going? We had Miguel Oz as well earlier, so a 29 and a 14 month. You guys all have these big numbers by your names. It's amazing. Oh yeah, we're running HW info, so I know if this computer fills up. Just like to keep a monitor on my Stream Deck. All right. Am I ready to start talking? I had 2 cups of coffee today, and then a leftover quesadilla, which is why my glucose levels are doing what they're doing right now, which is being jerks. But I did take the SGL2 inhibitor. I think it's SGL. Whatever it's like salt and sugar inhibitor. They've been extremely effective with me. I'm not supposed to take them while on this system, this feedback loop system, but I wasn't supposed to take them on the T-Slim feedback loop either. I'm taking a much reduced dose, so I pretty much take it on demand, like once every 2 days, I think. I'm taking the SGL2 inhibitor to keep a very low level going so that I can use a lot less insulin and not burn through all of my pods, because I don't know what the fuck is going on with my supplies of them. Not to mention the affordability of the pods. Jesus Christ, those things are fucking expensive. But in order to get enough of them, I need a pod every 2 days instead of every 3 days. And I contacted my doctor to get a prescription to tide me over until I could renew the prescription. And they just reissued a big prescription for everything. So I'm going to call insurance in the next couple days and be like, hey, can I re-up the prescription earlier instead of getting like a one to tide me in the interim? Complicated instructions are just completely beyond my doctor's ability to do stuff. I don't know what it is. I think they have a new person doing all of the prescriptions there, because they have a separate person that does all the prescriptions, approved by the doctor, of course. But if basically what I told them is I need a prescription to hey, I talked to insurance. I just need a prior auth and a prescription that'll get me to the next refill. That's what they said. And they're like, oh, okay, so are you on the Omnipod 5 or the Omnipod Dash? And I'm like, it's the Dash pump, not the Omnipod 5. Okay, here's a prescription. They gave me the wrong prescription. Like, every single time I give them just a little bit of wiggle room. Yeah, quesadillas. It's not all carbs, but it is mostly carbs. And it wasn't a whole one. It was only a little bit of one. But the problem is, like, man, I need to be fasting most of the time. The pods, I can't burn through pods that quickly, and it's a good incentive. I've got like probably 100 extra pounds on me right now, which is real bad for insulin resistance and all that other stuff. There's no excuse. I should not be fat. So I need to reduce my intake. So under the scheme of the keyboard, yeah, I took away start soon, so let me fade out the music here. Under the scheme of the keyboard, yeah. No, let me start over. How do I pause? There we go. Yeah. So, hi, hello internet, I'm back. Wednesday, of course, I typically don't stream. I would have liked to stream on Wednesday. Deep dish quesadillas, so it's deep dish anything sounds like it's all carbs. What's up, Project 4x4? Not 4x4, 454. Yeah, what's going on? New puppies here, so I've been super busy getting scars on my hands from puppy teeth. But other than that, I've been working on resurrecting my keyboard because I spilled iced tea on it. It was a code 10 keyless, and really good keyboard. I really like the feel of it. I like all the mechanical stuff of it. There's a little bit of room under the circuit board, and we're going to use that to our advantage, since the thing that probably died on this keyboard wasn't the matrix or the diodes. It was probably the slightly more sensitive Sonics. I think it's a Chinese microcontroller that more than likely just shit the bed. Its crystal probably hates us, and that's why it died when it was exposed to iced tea. So we're trying to reverse engineer the keyboard first, and then get a new keyboard system going. So what exists in the mechanical keyboard world is a system called QMK. I don't know, quick mechanical keyboard or something like that. It's basically you compile it and then you throw it on your microcontroller device, and I think it needs like a greater than 8-bit. I think it needs like a 32-bit microcontroller to function properly, which is a little bit much for a keyboard, but that's what the hobbyists have created. And then it runs your own custom code that you can build off of like a form, you know, like a standard form. You can choose a keyboard type that you'd want to load in. Sometimes you can reflash a keyboard, like an Atmel AVR keyboard, in order to make it have your own software, and then you can have your custom macros and all that fun stuff. We're just trying to get a keyboard working, but the problem is code 10 keyless not supported. The Sonics microcontroller is an 8-bit micro, so there's no reflashing it. It's, I don't know, it's one of these proprietary industriosphere kind of, you know, private keyboards, I guess. Private microcontrollers. I don't know. Either way, I want to get this software running on it. It turns out that QMK recently was sort of tooled to run on a Pico Pi. So a Pico Pi is a microcontroller that I recently was conned into buying because it was $4 each. So the Raspberry Pi Foundation created their own chip, and it's actually a pretty nice little microcontroller. It's fast. It runs MicroPython, among other things. Among other things. We can run QMK on that Pico Pi, and I got a bunch of them sitting around. So that's the idea, is that we're using stuff that already exists in the shop to create a project out of the things that I've been meaning to get to. So we've been meaning to get to the Pico Pi, and sort of that's where we are. What is this case here? What is that? Oh, extra tweezers, right. Okay, sorry. I was wondering why. What is this like case that's sitting in my view? Yeah, so we're trying to use stuff that I have already in order to make a keyboard work. Well, it turns out, according to the way that the code 10 keyless is wired, it's crazy pants all over the place. It's not like just a grid. Because generally when you do like keyboards and stuff like that, you don't have 105 inputs on your microcontroller. Unless you're a psycho, right? That's just a waste. Because the human interactivity layer exists on a time scale that is just glacial compared to how quickly the microcontroller does its things. Microcontrollers do things in a time scale that you are best to separate from your own perception of time. Things happen in periods of time that you can't fathom. That's how quickly microcontrollers work, even your most basic ones. So it doesn't make a lot of sense to have individual inputs for all of your buttons and stuff. Now, if you're talking about like a game controller and you've only got so many buttons, it's nice to have them all on separate things, because then you can look at them all at once very quickly, and you can do all kinds of different things with that kind of speed. We can't really get that with keyboards. We got like over 100 keys. We're not going to waste over 100 input pins on our stuff. So in order to reduce the number, what you do is you set up what's called a matrix. Hire Keanu Reeves, and then you get a writing team going. No, you set up a matrix, and so you've got rows and columns in a grid, and it looks a lot like It looks like my friend's Mixcloud. What the hell? No, it looks a lot like, did I close the window? Control Shift T. I did. Looks a lot like, well, that's kind of a weird example. Hold on, that's a weird example. We don't want that one. We want something like this. So you have, here, view image. There we go. So you got rows and columns, right? What we have here is 369. We got 9 buttons. Yeah, we're doing Pico Pi, which the involvement of Pico Pi is not all that immense in this project. It's just basically the vehicle by which we're running everything. We'll get to that in a second, though. So what you have is rows and columns, and then you isolate them with a diode, right? This is pretty much the scheme of the code keyboard. When you have these rows and columns on your microcontroller, what you can do is you could send, you can send a voltage level into your row, and then you can scan your columns. So if you've got all of your rows and columns on your microcontroller, this 3x3 keypad, 9 buttons using only 6 pins. Hold on. There we go. So you got all your rows and columns on pins. If you just put a voltage level on an individual row, you can then scan the columns to see which individual button is being pressed. Now, there are more complicated things about keypads, like if, for instance, you hit one button and another button, it can get confused. But if you're activating the rows individually and you keep everything nice and separate, that's great. This is basically how the code 10 keyless works. There's a bunch of diodes all over the circuit board, and I've reverse engineered it for the most part. They have arranged those rows and columns to be all over the place. So the thought for a little bit was, because we're running out of pins, right? There's so many buttons on these keyboards that even with this row and this column scheme, we're using up every single GPIO on the Raspberry Pi Pico. And that means I don't get any other features on the keyboard. That means that I don't get LEDs to tell you if numlock is pressed and all that stuff. That means I don't get backlighting control. So that's not gonna fly. It needs a lot of inputs for even for a 10 keyless. So we've got to come up with some other kind of scheme in order to run things. So we've got a matrix. We have to activate a positive power signal on the rows. We don't need a GPIO for the rows. So the thought is we can just throw in what's called a multiplexer, hence the title of the stream. A mux or a demux, right? So a mux and a demux, what do? Well, what you do is you give these 3 pins and the enable pin what is ostensibly a binary number, right? You would enable the chip, and then you would give it like 001, and that would activate switch number 1, and it would connect the common pin to number 1. So what you can do, you put that common pin to positive power, and now you have a means by which to activate 8 rows, and you're only using 3 pins really, because this would always be enabled. I guess we'll use 4 pins to create 8 outputs, right? So that's demuxing. And it's not necessarily demuxing a complicated signal here. This is a very simple setup. In fact, having just V plus on that means we probably could get away with having some kind of like a logic system on that instead. Some kind of a different chip that doesn't do such complicated switching. But we're going to leave it at that. We're just going to leave it like it is. These, I believe, do analog signals as well. So I don't know what we're going to get out of this whole system, because we don't need this to do analog. We don't need the other one to do analog either. So if we run into slowness with this, we're going to have to get pretty clever. The other way you can save pins, and the thing that we're going to try today, if we can get all the way to it today, is we are going to use these multiplexers in order to this would be technically demuxing the positive power. This is muxing. We are taking a bunch of pins and we're putting it onto one single pin. I figure if I2C, the digital inter-chip communication scheme, is fast enough to take button presses on a split keyboard, then using one digital input, in this case GP2, for 15 technically, 15 rows of information, or columns of information, then I think we can get away with it. I think we'll be able to activate one of these, scan all of these, activate the next one of these, scan all of these, etc. I think we'll be able to do that fast enough to get all of the information that we need to get. And if we run into trouble, we can double the speed by putting it to 2 different inputs, if we have that kind of control in QMK. This is asking a lot of QMK so far. Now, in the reverse engineering of the keyboard, I found out the rows and the columns are as such. These are the ones that are assigned, and I'm doing it by pin. Well, no, this one is by, yeah, that's by pin. So that's by microcontroller pin, but we can see what the distribution of the keys is. It's not as tight as it could be, and I guess maybe the extra spots are just there for like a more extended keyboard, like if you actually have a number pad. But the only thing that I can see in here in terms of what functionality we can get out of, you know, what was the purpose of this? These three columns don't really do much with a lot of their surroundings. You can see nothing's going on up here, and all the way down here, there's just nothing, right? What that means, and look, column 25, bud, what are you doing? So what I can do is I can connect column 25 to column 24. And with the same rows activated, it's not going to make any difference because there's no key right here. So we're going to turn 25 into 24. And then we've got 2. We've got a block of 4. Well, that block of 4 can be shifted to any of these. So what we can do is we can take 18 and 14 and double them up. And then 24, 25, we can just put over to 15. And so what that'll do is that will reduce the number of pins that I'm using from 18 to 15. The importance of that is that now we have a division of 8. Well, we have something within the division of 8, right? So if I left like pin 18 as it was, or just took 24 and 25 and then shifted them out, then I would have 16, which would be 2 entire ones of these. So that's basically what I'm doing here. I'm doubling up on the columns in order to facilitate, you know, using only 2 of these things. Whew. Okay, so QMK, where am I with QMK? Well, I've gotten, after restarting the computer, which is where we left off yesterday, I've got the QMK MSys, and I've gone through the tutorial and compiled keyboard code. So that's where we are with that. I would like to get a hello world going on this thing. So let's go back to the Adafruit tutorial and see what they have us doing next. Just so that we can get an idea of how the system works. I mean, it was relatively easy command line stuff. I really didn't have to do much with this. But yeah, we can edit the code in Notepad++, and then we can compile it over here. And I need to figure out what keyboard I'm basing this off of, because we're going to be modifying all these files. The GitHub stuff kind of scares me. I don't know what I'm going to be doing with that. I don't know if I need to actually... I tried to search for Oh Bother. I got a page full of Willow's chew toy results. What? Yeah, we'll figure this out. So yeah, okay. Where are we with the tutorial? I want to get QMK working on the breadboard, and then we need to build the circuit that's going to do the muxing so that we can do a speed test on it. And that's the important thing. I've used Git before. I mean, I have an account and everything. I don't know if I need to like do a fork and a clone and stuff like that. I'm not good with this stuff. But it's all in the tutorial. Where's the tutorial? What did I do with the tutorial? Hello? No, I just closed it. Okay, there's the tutorial. So yeah, this is what we're following. So yeah, I mean, so far so good, right? We got all this stuff. Yes to the question of the clones and stuff like that. Goody. Uh-oh. Uh-oh. We're in for some chop, huh? So QMK command available. Copy the source code. It didn't like my my network drive for this. So, all right. Back to CircuitPython or Arduino. Your RP2040 is fully reprogrammable through the RPI, RPi2. What? RPi RP2 bootloader, but when automatic reset to upload from Arduino environment does not work, and when the board has QMK installed, instead you need to manually access the bootloader. For more details on how to access the bootloader, check the guide for your particular board. Double-click reset. Yeah, fun. Exactly. The reset button is available. Hold down the boot button, click the reset once, hold down the boot button while plugging in the device. This is the part that we don't know yet. So I guess we need to Pico Pi. Getting started. Oh, is this going to be like in the, does the Arduino upload to it? Hold on, wait a minute. Oh no, I don't have, do I have the latest version of the Arduino IDE in here? Well, let's see if it's in the boards manual, the boards manager. Because if I can fast track it by just having it in Arduino, that would be neat. MCP 23017. Huh, that seems familiar. File. No. Tools. Board. Digistump, TCDuino, Atmega. Yeah, I don't think Pico Pi is going to be in any of this stuff. So we need to go to the boards manager. And we just need to see if the, I don't know if it's going to be, I don't think it's going to be listed. We need to go to a different tutorial. Yeah. Arduino Mbed OS, RP2040. So, I mean, technically I could potentially maybe upload it for using Arduino Mbed OS RP2040 boards. Mbed, huh? I don't know if I should do that. I don't know if we're going to use MicroPython or what, but we need to get started with the Raspberry Pi Pico. Let's just see what that's going to be like. This is going to be just the regular old datasheet. Colophone? What'd you just call me? Blah, blah, blah. I need a tutorial. I don't need this. This is everything, isn't it? Oh, here we go. Raspberry Pi 4B, Raspberry Pi 400, most installation steps, include getting started guided, blah, 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 blah. Setup scripts with 2.5 gigabytes. What the fuck? On your SD card. This isn't an SD. This is just a, hey, TurboNad, how's it going? We're still in the throes of building a keyboard. Figured I would do, we're going to mux and demux because it sounds more Mad Maxy. But yeah, using all these Max 308s that I have in a bin. Is it only applicable to the 4B? It's like a little too universal of a tutorial. We may look up a different tutorial. But anyway, the point of what we're doing is we're trying to get software running on this thing first. And then once we do that, we can come up with a quick code that's going to do like basically implement this full system of the mux and demux that will allow us to test the speed of the muxing and the demuxing and see whether or not we could hook like one row and like 2 columns up, and then we can see if pushing the buttons is fast enough for us. We don't need the diodes if we just do like isolated stuff. And then we can start hooking it up to the real deal just to see. I just need to see the speed. I need to see the speed at IRL just to see what we're in for, right? Let's look up like a Raspberry Pi Pico setup. Let's find like a different tutorial. Tom's Hardware? Yeah, all right. I didn't know Tom's Hardware had articles like that. That's pretty cool. So Hello World with a microcontroller is just blink an LED. That's it. Which is oftentimes people think it's completely trivial. We had Chester Second Egg in the Discord talking about how he just got like a model sim working after like 10 days of billable hours, which is insane because they probably should have done like a 2-hour like tutorial on how to get everything working instead of just jumping into a client project with it. Because like Hello World, you're like, I'm not a basic bitch. I know what I'm doing. I'm not going to do Hello World. And then you end up spending 5 hours because your cable isn't a USB data cable. It is a USB charging cable. I've heard this and done this before. That's rough. Hello World is the important step that's going to let you vet out all of those little speed bumps along the project. So blinking an LED might be what we're doing right now. It's so simplistic, but yeah, those cables get the scissors around here. That's my bottom line. That is my bottom line. You got your Raspberry Pi Pico, but how do you use it? Yeah, great fucking question, Tom. Oh no, it's by Les Pounder. The Les Pounder. I'm not gonna make any jokes. You got a Raspberry Pi. Somebody who has a vaguely easily manipulable last name. I solidarity, my brother. You've got your Raspberry Pi Pico. How do you use it? Let's show you how to get started with the latest board. Hell yeah. We've updated this guide to include the Raspberry Pi Pico W. Well, that doesn't apply to me. We don't have wireless. I don't need wireless on any of my keyboards. I appreciate having cables that can't have a snooper. I like it when the only wireless signals that exist in my room are for my pancreas. The Raspberry Pi Pico is intriguing board. All right, let's not get into. All right, rather than another Linux single board computer like every other Raspberry Pi, the Pico is a low-cost ARM-based microcontroller which we can program using C or C++ and MicroPython. I don't know if we're going to get into MicroPython for this. I'd rather use this one right here. But this tutorial we would introduce how to get started with the Raspberry. And I think QMK exists in. What does this exist in? Use the source, QMK configurator, graphical interface, key map, key codes, QMK firmware, blah, 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 configuration files to do. What does this exist in? Oh, it's ARM. Product line, Atmel AVR, Doxify, GitHub, documentation, keyboard, keypad. QMK is developed, maintained by the blah, blah, blah. I don't know, man. I don't even know what the hell kind of thing it has. Oh my god, there's so many files. I keep going to the same one. Schemas. What am I looking for? I do not know the language. I don't know the language. Hex, it's so maybe C or C+. I don't fucking know. Oh. No, that's everything. So it might be Python and C++. Keyboard, Hacktoberfest, keyboard, C++, all spelled out. So it is C++. All right, so we'll concentrate on that. Intriguing board, blah, blah, blah. Pico low-cost ARM-based microcontroller, which you can program C, blah, 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 MicroPython. This tutorial is how to get started, blah, blah, blah. Raspberry Pi Pico. If you'd like to know more technical details about the board, take a look at our review. Okay. MicroPython UF2 file for your model of Raspberry Pi Pico. All right. What is that? Drag and drop MicroPython. That's for MicroPython. I would like to use C++. Plus. Boot select button, blah, 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 blah. That is that only for that? Or is that how to set up the Raspberry Pi Pico? I guess I need to do this. Okay. Pico W. So we want Pico. This one right there. Download that UF2. What do I do with the file? I don't like open it. Image credit. Future? They got this from the future. Oh my god. How come the Raspberry Pi... What is Tom's Hardware doing with a time machine? Push and hold the boot select button on the Pico, then connect your computer using a micro USB cable. Release the boot select, and it appears on your computer. We can do that. That's easy enough. Let's see. Well, you guys can see through there. And then I need a USB cable, and I need my foot to not be asleep anymore. I was sitting funny. I mean, this is like a... Oh, that's USB-C. Okay, where's my USB? I have a cable that I commonly have sitting around this desk here, and I don't know what happened to it. Let's get the soldering iron wire out of the way. We'll need you later. Now, hopefully, given the speed that projects go on stream, I hope we can get to hardware today. The software shouldn't be too hard. I know how to compile it now, and as long as we can get our tool chain going, we'll skip over to hardware, and we can quickly build up a triple Max 308 circuit. What is this? This is a power cable. What happened to my programming cable? What happened to that one? Okay, hold on. I gotta find it. Things get kind of like pushed to the side when they're not in use around here. So I think it ended up like all the way over here. I think it's all the way over here. That's not it. That's not it at all. My God. Ah! A little bit of an avalanche. Labalanche. Nothing. Where did my freaking USB cable? I probably like organized it, and so it ended up in a completely separate location. Never follow an engineer to a second location. What is this one? This one goes around there. That's my mouse cable. Okay, never mind. All right. All right, I gotta travel to get. Wait, what's this one? Yep, there it is. There it is. Why is it on my other computer? We're gonna. This one might not. Oh, that's USB-C. What the hell? Nope, that one's wrong. Completely wrong. I have like a thinner cable that I like to use for programming stuff, and I just gotta find it. Or maybe just designate a new one. Yeah, looks like we'll use this one. Okay. This'll do. I think this one came from Steam. From Valve. It's a Valve cable. All right. All right. Let's get started here. So, plug that into USB, and then on the microcontroller. Okay, everything's falling apart. Everything's falling apart. Everything's falling apart. Stream canceled. We'll do that, and then I'll do this. Bring you guys up a little bit. And then I got a cough. Bleh. Okay, hold this down. Plug it in. There's nothing else hooked up to it. And then, presumably, something is supposed to be happening here. Like maybe I need to go into my folder. RPi2, E drive. Cool, okay. Index, info, UFO, UF2 bootloader 2. Model Raspberry Pi RP2. Board ID, RP2. There's a lot of 2s going on right now. All right, so there's all that stuff. Cool. So then, presumably, this thing that I just downloaded. No, I don't want to open it. Show in folder. That folder? Hello? Where's my UF2? Raspberry Pi 2 Pico unstable version blah. Okay. So this into there. Drag and drop. UF2. Reboot, and now run MicroPython. That's if I wanted to do MicroPython. How to blink an LED. Further testing successfully programmed the Pi. We should write Hello World equivalent for hardware projects. Hey, Celia. I mean, there's an onboard LED that we could flash too. I'd rather do the onboard LED than having to do that. MicroPython syntax, simplest form. Before you start writing any code, first need to write up our test circuit. 330 ohm, an LED. You probably should go with a higher than 330 ohm resistor because you don't want to blow your eye sockets out. Build this project, blah, blah, blah. Insert the Raspberry Pi Pico to the breadboard so it sits in the central channel. Okay, yeah. Why are we doing it that way? Usually I reserve the outer rows for the power and ground. I would rather jumper power and ground to the outside and then run like the LED off to the side of the board and have the resistor then go to a rail. Whatever, doesn't matter. From machine import pin, really? How do you do that with, our code is written in the large blank space above the REPL, and we start by importing 2 MicroPython libraries. What are we writing this in? Did I skip stuff? I didn't skip stuff. We didn't install any kind of a, oh, here we go. Yeah. Python shell, otherwise known as, okay, so So this is if we're doing MicroPython, which I don't know if we're going to be doing. Now, what we have, what I've compiled already for the keyboard, let me open up that folder. That's actually going to be in the base C drive. Or no, C users. And then no bother, and then it's going to be... what was it called again? Like QMK something or other? There it is, QMK firmware. So I've got this. Platformio doesn't quite work. What's up, Copper? Good morning. Yeah, I don't, so we're not, the goal here right now is not to learn how to program MicroPython specifically for this microcontroller. The goal right now is to get familiar with Hello World and to make sure that our hardware, the base hardware, works so that we can get the tutorial for the QMK keyboard stuff working, which I need to see whether it exists in MicroPython or C++. And then we need to figure out what we're doing with that. I think I can Notepad++ edit these files, and then when I compile it, then we put this stuff on there. So this is a hex dump. So how does that work? Hold on, let's go back to the Adafruit tutorial just to make sure. 4 shots of espresso. I had 2 cups of coffee today. That's all I got going for me. QMK command available, an up-to-date copy of the source code in QMK firmware folder within your home folder. Following pages show how to build and install a firmware. That's what we're looking for. Yeah, so I've done all of this stuff, right? Actually, I don't think I've done this. Clone the firmware to install dependencies. Oh yeah, okay, yeah, I did do all that stuff. Once this is done, you'll have the QMK command available, up-to-date copy of the source in QMK firmware folder. So that's this. So QMK firmware, here's all the stuff. Following pages of this guide show how to build and install a firmware. And we're not switching back. Fully reprogrammable through the RP2 bootloader, but automatic reset to upload from the Arduino environment does not work when the board has QMK firmware installed. Instead, you need to manually access the bootloader. More details on how to access the bootloader, check a guide for your particular board. We did. So we hold down the button and then we turn it on. Okay. Once your computers recognize the RPi RP2 bootloader, you can either drag a new UF2 to the drive for CircuitPython, QMK, or Arduino, or initiate the build upload of a firmware Arduino or QMK flash. But ready to get down to business. Well, yeah, that's why we're here. Compatible hardware, other pages, guide, flash, QMK, firmware, 24, to learn more about how to modify and customize QMK along the way. If you don't feel like compiling the software right now, we've also provided the UF2 file. So it's all about that UF2 file, right? Someone in the house is an espresso maker. The increase in quality because of freshly ground beans is amazing. Yeah, that's always nice. It's always nice. So they have an example file. I've compiled, I mean, I followed their instructions. So is there a UF2 file? An UF2? Fucked if I know. Config, make file, MDs, hex. We got hex. But hex needs to be flashed for the flasher. Build data docs, drivers, keyboards, platforms, quantum tests, core users, and util. I mean, is it in build? I don't see no UF2 files. So I don't know if it fully compiled. But then again, I've got all this stuff. Firmware sizes of blah, 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 blah. Default.hex. Hex to QMK firmware folder, elf, C. Yeah, so it compiled as hex. I don't know what we're supposed to do with that. Let's just see where the tutorial goes, I guess. Because, I mean, this is what it's all, this is what we want to learn. I mean, that right there is literally what I want to test. I'd rather have it with the screen, but some keyboard definitions are designed for the RP2040. A simple example is the one-key keyboard. You can easily test this on a breadboard with a Raspberry Pi Pico and a simple button. This is a great way to get started. This guide shows how to build the firmware file yourself. That's exactly what we want to do. But you could download it, you could cheat. You could download the save file and cheat. All right, we might as well just follow this guide then. So let's get a button. One singular button, which I have. I have a couple little buttons on a perf board that we can throw on this thing and test. Let me get ready to do this. I'll just go to this view and then move this over here. And let's get a jumper wire kit from up on the desk over here. I gotta dig for it. Got it. I ordered a pack of a couple of these. I guess this passed quality control. It's also covered in dust. Ugh. My brain for 3 days to get the compiler to work right? What? No, I mean, we've got the compiler working. That's fine. It wasn't anything complicated because this is specifically for keyboards. It's not for doing other stuff. We're literally just running their... How's this thing open? I don't want to send jumper wires all over the place when I open this thing, but it's not... Oh, there's another piece of tape on it. Yeah, we're just doing the keyboard stuff. So if we just follow the Adafruit tutorial, they should get us they should get us started with being able to load code onto this thing and get it working. I don't think it's going to be a multi-day affair, you know? Obviously, we might not know. Found out with Pico and CircuitPython, MicroPython, it's default with debouncing. So if you don't want that, I don't know if I need debouncing. That's a good question. Do I need debouncing if we're going to do multiple... What the hell? Must have touched something greasy. That's weird. If we're doing multiple muxes and demuxes, oh, look at these puppy teeth marks. Stupid dog. She doesn't know. She doesn't know. She doesn't know how strong she is. How strong her jaws are. They're like little vices with needles. Okay, let's see. We're not looking for like more universal stuff. We're looking to do specifically a keyboard. And so I'm gonna be getting into that. Debouncing, I'm not sure. If we're gonna be scanning, if we're activating a row and then we're scanning the keys of that row, I don't know if we need to debounce or not, because that scanning activity makes it so that I don't know if we'll get a bounce on the key. I don't know what kind of speed we're gonna see out of this thing. We probably do need debounce, but they use the old bounce library. They don't use bounce 2. Okay, anyway. So we're connecting this to what? According to the tutorial, a very simple tutorial, GP4 and GP5, which are on that side of the board. And they're way up here. And that the Raspberry Pi Foundation, ladies and gentlemen, they've decided that if you buy their $4 microcontroller, all the markings for the pins are on the other side of the board. Yeah, no. Optical switches. We don't have Hall effect sensors either. This is literally we're just bootstrapping onto the back of this fucking thing once we pull out all of the hardware that we don't want, which is a lot of it. We're going to bootstrap onto this thing, and then we'll be able to perform a takeover, and I'll have the Pico Pi just double-sided taped to the underside of this thing. Jumpers, check. And then we're just doing one singular button. And that, hold on, I got to pull up the other web page. Where's my mouse? There it is. These seem very simplistic, but they're very necessary to do. So I'm literally just connecting across the 2 leads of the button. All right, easy peasy lemon squeezy. Let me turn this thing around because it'll be a little easier. A little bit easier. I'll leave some room for the screen. Leave room for the Lord. Wonderful thing about these jumper kits is how limited they are. The person who made that silk screen should be slapped. They could have at least given us like a 1-letter silk screen on the top side. You know? Because if the, I mean, you got to assume that everybody's using solderless breadboards, right? And it's like I can't see shit. Like, I don't know what pin is what. I don't have a mirrored surface underneath this thing. Best thing I can do is spend an extra $4 and just have another Pico Pi sitting in the wings, which, by the way, we're going to use one without headers on it. So we're going to use this one as our actual runner, and then we have one that's configured specifically to go in solderless boards so that we have one in the future in case. But yeah, best thing you could do, just have one sitting by the side and just go boop 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 boop. Wait, that's not right. It's those on the other side. So we are connecting between 4 and 5. So 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. I probably don't want to block all those pins, so it'd be better just to pull that down and then over. So down and over. There's my Philadelphia showing. Actually, a little bit New Jersey. A lot of my mother's side of the family. No, actually, both sides of the family are originally from New Jersey. Move this one over a pin and then do this one right next to it. Okay, so there's our first button hooked up. It's not exactly like the tutorial. Oh my God, it's Twisted Sister. 57 months. Dude, thank you. Thank you for subbing for so long. I appreciate that. How you doing? Yeah, I got puppy scratches all over me from the new dog. All the training to be replaced on game day. That's how it go. That's what we do here. Just trying to get that to be like a little out of the way. I like to do things like that. But yeah, thank you for the 57 months. And yeah, hot glue. Yeah. Okay, so this is Hello World, right? So we're hooking that up for a single keyboard thing, right? All right. Single keyboard, GP4, GP5. Open up the terminal command window, change the QMK firmware directory. Why are we always doing that? I get it. So we change our default directory. So I'm going over to, let's, hold on. I gotta rearrange windows again so it doesn't look like I'm looking at my belly button when I do stuff. So we go there, and then I move this over, and then we get the tutorial back over here. There we go. Sorry about all the shuffling. I need to set up to have 2 monitors on the top deck of this bench, because that'll alleviate the problem of me going like this when I'm looking at code. Plug in your Pico. Hold on. Next, plug in your Pico while holding on the boot button so the RPi 2 drive appears. I did that. To build and install the firmware, use the following commands. Okay. Wait, did we already change our directory? No, we're starting again. Okay. CD, QMK firmware, QMK flash, keyboard, hand-wired 1 key. Produce a lot of output. The start and the end should look something like this, and that'll produce a UF2. I guess, oh, because we're specifying RP2040 on it. I see now. Man, this stuff where you've got like multiple different processors is crazy to me. Because we're gonna have to go in and, you know, mess around with all the little stuff. But yeah, let's get this done, because that way we'll at least have the confidence that we can produce proper firmware for this thing. Let me put my non-sponsored soda over here, and let's do some command line stuff within the QMK cases. So the question is, do we just, I mean, this isn't starting from new. Should I close it and reopen? I'm going to close it and reopen it just so we have a fresh starting point, just in case the directories are weird. So QMK MSys is what we installed last time. So we've got our default directory and everything, right? And I've run QMK setup and I've done all that stuff. So what we're doing is CD, I don't even know if this is going to be applicable. Oh, I don't have tilde. How do I get to tilde? That's an escape button. I need to go function. No, function shift this button. There we go. It's a very limited keyboard that I have on this computer. So there's a lot of a lot of function keys in order to get to stuff like this. It makes terminal stuff a little bit annoying. So QMK firmware. Okay, that worked because the GitHub directory has been cloned onto the desktop. QMK flash KB is hand wired. One key. Can I tab complete? Doesn't look like it. One key RP, yeah, 2040. I keep trying to tab and it won't. Did I accidentally put a space in there? Dash KM default compiling key map, make jobs, default flash, QMK firmware 0.18.2. Well, now we wait. Now we wait. We get to wait. We get to sit. We get to wait. I'm getting bored of waiting. So yeah, this is apparently how we compile it, and then we get that file that we can then just drag and drop into the controller. Which means that if I want to update the firmware on this keyboard, I should probably drill a hole wherever the reset button is so that I can access that from the outside of the case. Or I can position it strategically to be where the jumpers were on the old keyboard, so that there will be a nice big opening where that reset button is. I use tilde all the time, but I couldn't recall shift minus? Quote? Huh? As its code, I'm old. Yeah, I don't know. This limited keyboard makes it so that I have to like bend my hand into it like a claw in order to put a tilde in. Compiling. Cool. There we go. We'll give it the width that it needs in order to look nice. Boy, you know, configuring a keyboard in like a Teensy is not this involved. You just pull from a pull-down menu on a Teensy. You need a pull-down menu, you got 2 lines of code, and you just hit go, and it kind of does, and it just kind of works. This 32-bit shit is crazy. I don't know why. I guess they're just making it easier for people who are more into full system programming instead of low-level programming like I do. Look at this. Look at all these definitions for like I2C, I2S. Are you doing anything with this? We're pushing one button. One button. This is a lot. Well, I guess if we get up into the higher functionalities of the keyboard, it makes more sense. Like if we involve a configurator thing. Yeah, it's doing crypto mining. Got to do that crypto mining. Got to get into that grind set. I'll be happier when we're building hardware. Oh my God. The only problem with what we're doing right now is that I'm going to spill something on the keyboard when we're done, and it's going to explode. It's just going to fucking explode. Unrecoverably. Bootloader not found. Make sure the board is in bootloader mode. It is. Well, it did. It's in bootloader mode. Literally got a folder. What am I supposed to do? I mean, I guess I could just cancel it and drag and drop the file. You literally have... You think it times out? Does it time out? Let me just do it again then. Yeah, there it goes. Okay. There it is. It did time out. You're right. All right. Blah, 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 blah. Produce a lot of output, etc., etc. The computer may notify you the new keyboard's been connected. It is not. When you press the button, it will type the letter A. Yep. 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 Mm-hmm. 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 Yeah. Okay. Okay. This is pretty much a mood. This is a mood right here. This is a mood. Ah! All right, so the keyboard works. We're done. See you later. Really? You're going to do a Fonzarelli reference? You're going to do Fonzarelli in that one, huh? Schmide, you're dragging my stream into Boomersville, and I don't like it with all your boomery references. Quit boomering my stream. We need to be more zoomery, and the existential crisis of an indifferent world is why we are going ah instead of e. See that? Now I'm dragging it back over to the zoomers. To change the key, you can open the file. I really don't want to, but I guess I will. I'll do this just so I know what's going on. QMK firmware, keyboards, hand-wired, one key, key maps, default key map. Bop. QMK firmware. Keyboards. Hand-wired. I guess that's where we're going to live, is hand-wired. Oh my god, look at all these keyboards. Feels. Is that a meme board? Hand-wired. Hand-wired. Oh my god, there's a lot of these. One key. Oh. One key. There's like a 5,000 of these. What? How are there 5,000 one-key keyboards? Man, maybe we should have used this to make the octo pedal. Well, then we couldn't have fit it on such a light microcontroller. Key maps. Default. Jesus Christ, this is extensive. Include QMK keyboard H, constant uint 16, progmem key maps, Jesus Christ, matrix rows, matrix columns equals layout ortho 1x1, KCA. Holy fuck. KCA. KCA, for instance, to make it a mute button, keyboard KB mute. So there's going to be like a document that lists all the different keys, I would assume. Special key will mute and unmute the computer's main sound output. QMK has a frequently asked questions page about keyboards and key maps. Full list of key codes. Yeah, there's the full list of key codes, which we'll need later. We're not there yet. Look at all these keys. Oh my god. Over there, learn more about the possibilities. Macro pad with QMK, no. What about the screen? They show the screen. Shouldn't we be able to see the screen? I don't care about the macro pad. Gherkin. Looks like a pickle. Hey, Lime2186, thank you for the 256 bits. That's a lot of bits. Jesus, thank you. Thank you. Yeah, we're messing about with QMK today, and we're trying to get an idea of how this stuff works. So we already have a key that types A. See that? See, it types A, just not a random key. Is random in the keyboard maps? Hold on. I mean, you could always program a random function. You could probably take it down to a like a singular like a number that would define it or something like that. What list of all key codes? Control F, random. Nah, looks like you'd have to make a little bit of code to do that, but that wouldn't be too hard. You could do that. You just might have to have like a lookup table. A big old lookup table. Okay, so with the Adafruit tutorial, I feel like we are getting on pretty well with knowing about how to put this stuff together. So basically what we need to do, I don't think we're going to start from scratch on ours. I think what we need to do is we need to start from a known location. because we need to make our own key map. Our own key map is going to be sort of the linchpin of this operation. And we need to actually make it so that as it scans through the rows and the columns, it will use a demuxer in order to do that. Now, I found a project that does that. I found a default that does that. I would also like to get the screen working as well. Let's see if we can explore that while we've got everything on the very simple bench setup. One keyboard worth of 1-key keyboards and a metric ass load of USB hubs. And make it all use relays, so it's clicking constantly. Let's see. This would be 4051 multiplexers with QMK. So this is part of what we're going to be looking at. And then I can close this. I'll keep that up just in case. Compatible microcontroller, we don't care about that site anymore. Quick Pico setup, we don't care about. We figured that one out. That was as easy as it could get. Doesn't matter there. And then here we are at MicroPython drag and drop. That's where we're going to be using. That's what we're going to be compiling into. And then we'll need to learn how to program. Well, the QMK toolbox could also help us configure it, but I don't think it supports the following bootloaders, all this stuff. Lufa. I don't know if we're going to be using the configurator because we're going to be doing this on our own. My only question is screens. How do I get the screen working now? So the Adafruit pad thingy, they don't even have a picture of it. Cloud thermometer. Oh my God, that's disgusting. Don't get food this close to your lab, huh? Look at MacPad, blah, 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 blah. Keyboard, Adafruit, MacroPad, KM, default. How do I get the screen to run? I don't know if any of this stuff has that. Well, the MacroPad has a screen. So let's take a look at the Adafruit MacroPad. And that'll just be in the folders here. They have their own. We're still hand wired. So keyboards, Adafruit. There are a lot of damn keyboards. Abstract. Where's Adafruit? There it is. MacroPad. Config command H, 5 columns, 3 rows, direct pins. Huh. Clang format off, clang format on. OLED SPI defines 128 by 64, SH1106. All right, so which one do we have? Hold on, let me open up the thing for the screen that I have. I need to find it. This would be, hello, Brain. Brain, hello. The one that we have is, I'm just pulling up the page for it. Dog stuff, dog stuff, dog stuff, router stuff. There it is. My Amazon is all dog stuff. OLED display module for mechanical keyboards and Arduino, 3.3 volt to 5 volt, 0.91 inch. SSD 1306. Yep, SSD 1306. How'd you guess that? How much stuff with mechanical keyboards have you been doing? So we'll need to figure out how to define all that stuff too. And then we'll need to figure out how to do, I think we're, well, okay, so if I, how can I wire up a test with this? If I OLED SPI defines, or not, it would be I2C, so we need to find an example of something that uses this, a keyboard that uses this. So this is not the config H that we want. You got 40 of them at AliExpress. I probably paid a lot for this. Let's go back to the wired. I mean, like, I would love to be able to add it to this. I need to find an example piece of code that's going to tell me how to add it to that, and then maybe it'll work. I don't know. I don't know how this shit works. So hold on, let me go to our web page that has the tutorial on it. You add a fruit or otherwise. Maybe these guys? Really? You ordered 50 but broke 10? Is that for like classes or something? That's a lot of little screens. I just hope mine works. Command line interface. Customizing functionality. A lot of people custom keyboards more than about setting, but yeah, blah, 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 blah. Core quantum, key revision, KB map, key map user. Each of these functions described below can be defined with underscore KB suffix or underscore user suffix. We intend that you use the KB suffix at the keyboard revision level, while the user suffix should be used at the key map level. I mean, what we're doing is totally different. So defining key codes, programming behavior of the key code. We've got like a bit of a different hardware thing going on here. I think I just need to find key codes, software features, screen, hardware feature. Here we go. OLED driver, 1306. Shit. Wait. Oh, what's our 128 by 32? And it's 1306. Where'd our window go? Where'd my window go? I lost my window. 128 by 32. I don't, what's the, huh? ARM versus AVR? This just says Arduino. I don't know which one it is. Okay, hopefully it works. Oh, compatible with QMK. Designed by Nullbits. I mean, you can buy these everywhere. It's not designed by. Anyway, this is just like cheapy. All right, so what we can do is to enable the OLED feature, there are two steps. First, when you're compiling the keyboard, you need to add the following to your rules.mk. Oh God, rules.mk. Well, that's key map, so we got to go back to the folder. And we're in the Adafruit macro pad right now. So keyboards, hand-wired, EFG, if ARM or Arduino MCU. Huh? Yeah, oh, the micro, what do we have? What is the Raspberry, what does the Pi Pico count as? RP2040, is that ARM? On the display itself? I don't see any processor on the display. It's under things that I can't access. I don't see any kind of a thing on the display. I don't know which one it is. Well, they said it was, anyway, hand-wired. EFGHA. Hand-wired. And then we have, what was our thing again? It was like one button. What was it called again? One key. Wonky. Wonky. One key. One singular key. MNO. One key. Oh my God, there's so much stuff. Rules.mk. Layouts. All right, here we go. Boot magic enable. No. Mouse key enable. Sure. Why not? Doesn't matter. Doesn't matter. Doesn't matter. Backlight enable. No. We will eventually have that. Yes. RGB light enable. No. Now, the numpad or numlock, not numlock because it doesn't have, it's 10 keyless. Scroll lock and caps lock will have RGB LEDs on them. I don't know how that's going to work. N key rollover. Audio output. Yeah, no. Pro Micro 1 key Ortho 1x1. So what we need to do in here, and I don't know if this is kosher what we're doing. I don't know if we need to like spin off a new folder or whatever for this, but I'm playing around right now, and if I screw it up, I guess I can use GitHub to roll it back, right? So in order to enable this, we need OLED enable is equal to yes. Pretty self-explanatory. And then OLED driver. So OLED enabled Boolean OLED task user void. What the hell? Just default. This is gonna do a lot of I don't know what this stuff is. Where does this go? So that goes in here, I guess. If I save that, maybe that'll be okay. Then in the key map file, implement OLED task call. This example assumes your key map has 3 layers named, well, we don't have 3 layers, we only have 1 layer. Great example, guys. Logo example, here we go. In the default font, certain ranges of characters are reserved for QMK logo. To render this logo to the OLED screen, use the following code example. Default font files located in drivers blah 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 C, and location can be overwritten with OLED font H configuration option. Font file content can be edited with external tools. Oh my god. For some purposes, we may need to read the current state of the OLED display buffer. Not going to worry about that. Split keyboards, common to have 2 OLEDs. I'm only going to have 1. So if def OLED enable, and then we'll put this in there. So keyboard, constant key map, matrix columns. Oops, I collapsed it. So we do if def OLED enable, and then we punch this stuff, not this, we punch the logo into it. Punch that code in there. Now, I don't know about all the dependencies and the files and stuff like that. Yeah, the news radio ticker tape sounds. That's all we need. Shunk, 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 shunk. Notepad++. Sorry, I'm trying to concentrate. And then we end the if def with an end if on a separate line. QMK keyboard does that. Blah blah blah. Layout, A button, OLED enable, static void render, logo void, progmem quick logo, and then that throws up a bunch of values. Where are the pins? None of this stuff talks about hardware. This is what bugs me about these things. Where do we define the pins? In split keyboards, it's very common to have 2 OLED. Basic configuration, display address. The I2C address of the OLED display, font, start, end, width, height, timeout, fade out, etc., etc., etc. OLED displays, height 8, lock type 8. They just do they just ignore hardware? They always seem to do this. I mean, we're using the Pico Pi, so we need to figure out what it wants to assign for Pico Pi. Rotation. When I define it, it's not giving me any information about what pins it's on. Layered state, so that's all layer stuff. And then maybe I need to look at the driver. There's probably some other thing that I need to look at. Displays, quantum painter, LCD, OLED, and then it goes into lighting. But in OLED driver, they don't give me any other. OLED driver, supported hardware, usage, type. Okay. 11062 enabled rules.mk. So what is the file that we need? Yeah, well, it says I2C at the top, but like, zoom in on this. All right, these web pages, man, I'll tell you something. Oh, please, just show me the image. Oh, they got rid of my view image button, huh? Oh, it's just in that page. All right, I2C 0, I2C 1, I2C 0 again, I2C 1, I2C 0, I2C 1, I2C 0, I2C 1, I2C 1, I2C 0, I2C 1, I2C 0. Which one is it? Like, where are we? What, I mean, 1 and 2, they seem like a pretty good candidate. UART 0, TX, and RX, but I mean, I2C 0 and 1, STA and SCL are all over this thing. So which pins are I2C from this board? I don't know. That's what I'm looking for in the docs here is, you know, where can I find this information? And it's probably in whatever SSD 1306 driver exists within the project. I don't know where that information would be. Hand-wired 1 key, RP2040, config. Column pins, row pins. Okay, here we go. QMK weighting, bootloader double tap reset, RGB DI pin A1. So this would be, we need to find what the code is going to look like in here. Because it's not defined. That's the whole point. The point is that it's not defined. It needs to be in here in order for it to be defined. So we need to figure out what that looks like. And I love how the tutorial doesn't give a shit about telling you about any of that. It's just like, it's whatever. You'll get it to work. Address, font, start, end, width, height, timeout, fade out interval, scroll timeout, IC, no, column offset, update interval, display, custom, width, height, size, type, block count, block size, COM pins. Options are COM pins sequence, COM pins alt. What the fuck? Huh? How the chip maps its memory to display. Oh, no, that's not what we want. That's not what we want. OLED API. Rotation, keyboard user, clear, render, set cursor, advanced page. Oh my God, this is so much. This is way too extra for me right now. I would have wanted it to just like do something so that we could play around with it a little bit, but it's just so much. I gotta get a little closer here. Brightness, task, keyboard, user, scroll area. Driver conversion. Right, clear. This is old API, recommended new API. Okay, that's not what I'm looking for. Yeah, this is weird. I don't understand why there isn't more information about this. We're working our way slowly to the number of curses required in order to get this to work. It's a feature of the IDE, and TurboNet is very familiar with it. Excuse me. Maybe it's in the hand wiring guide? Well, maybe not. This is... Wait, what? Keyboard firmware builder. So I could actually define my rows and columns on this. It would be a very weird looking thing. Yeah, that might not actually. C++, etc. Huh? Interesting. Swiss helper. Yeah, so the hand wiring guide's kind of interesting. It's funny how they want you to use like this totally common layout where you just have your rows and your columns like make sense, but code decided not to do this, and so now I have to deal with it. OLED display. Look, it's the link we're looking for. Is this going to be the same fucking... Oh, this is actually a different guide. Well, this is exactly what I wanted to do. Yes. Okay, bud, you did a great job building this keyboard, but we need to talk about one, not using a Dremel, and two, how to file away all the apprentice marks. And or three, finding a 3D printer where you can print out a bevel for that will hide this Dremel overrun that you've got going on right here. I'm not insulting it. I'm giving tips. Giving tips. I choose the I2C because it's the least amount of wires. Yeah, I know that. I know that. SDA and SCL pins on your controller, as these will be used. See, like, okay, user guide. Boom, it's right there. It's right in front of us, right? Solid Electronics, 13 months. Hell yeah, dude. I have a perfectly usable keyboard, but now I kind of want to build one for no good reason. I know, right? It's a neat little project. It's a neat little project. I mean, we've got some weird stuff that we need to get working on this system. Looking at these people who are just building their keyboards straight up from nothing, they've got some cool stuff going on, but we can't just build this from nothing because of the way the layout exists in this keyboard. I could either alter the layout until I'm blue in the face, or we can make it work, but we can multiplex it. They got it working and moved on before cleaning it up. Yeah, that's true. I mean, you know, it works, right? So, and I'm probably not going to be able to do anything better than what they have. Choose the GPIO pin for reset. Heard it's not needed, but heck, if you have enough pins, might as well. There's already a reset button on the whole thing. Pull up resistors between SDA to VCC and SDL to VCC. Hold on. I have somewhere around here. I don't think it's open on this page. I had a Pi Pico schematic. Oh, dear God. I hope my glucose level wanders back down at a normal range. Raspberry Pi Pico schematic. Bada bing. Let's see if they got the pull up on I2Cs. Oh, no, they probably don't. No, they probably don't. So we need like a 15 kilo ohm. What is that frame? That frame blocks all the stuff. That's a weird one. All right, I2C pull-ups. I don't think they have them. Is there like an internal pull-up? What's this one? USB, okay. Oh man, I gotta go find some 15 kilo ohm resistors. That's always annoying. Yeah, okay. So we gotta find two 15Ks. Reddit page, there we go. Look up the SCAS, blah, blah, blah. Reset your choice VCC to VN, ground to ground, appropriate paths as a controller. Note the VCC on the OLED board is meant for 5 volts. If you have a 3.3, use a 3.3 volt pad instead of VN. This thing says it can do both, so yes, the wiring is extraordinarily complicated. SWI master and I2C master can go into your keyboard folder. I mean, I guess we could just start building the building the whole thing. Yeah, because we didn't even define I2C clock yet. Maybe we need to follow this resource. How do we start a new start a new project in this system? I guess I need to start from scratch. So let's just not like, let's not save anything. Let's just close these for now. All right, we got a couple different problems that we need to solve here, and what I'd like to do is first get the OLED working. So I kind of want to start from the singular key keyboard and move on from there. So if I take, I guess, only what I need, which would probably be key maps RP2040, config the H file rules, or can we start a new? Okay, you know what? I'm gonna do QMK start new keyboard, start new custom keyboard. QMK start new custom keyboard. Instead of like, how do we start from scratch? What's the command to create a new keyboard? There we go. What's up, Groovy? How's it going? Building hand-wired board. Remember there being a QMK command. Haha! Ah, yes. I relate to this very closely. I can just make a folder manually. QMK new dash keyboard. Yeah. Easy peasy lemon squeezy. Hey, get out of stupid. No, come back. I need you. Need you and I need you. There we go. So I need to, how do I change my directory? There we go. So QMK new keyboard. Name your keyboard project. Keyboard name. Code keyless. Bother key 4.0. We're trying to resurrect my code 10 keyless that I spilled iced tea on. Iced tea board is going to be difficult to type. Unti? That sounds too much like auntie. Like auntie. Like your relative. Mia. No. It's just like bother board. Bother board. There. That's gonna confuse me. Bother board. Let's do the proper one. So we'll just do bother board. GitHub username. Oh god. I don't remember. Git. Work verb design. Copyright, etc. Your real name. Yes, please. Please enter your choice. Oh my god. Oh my god. It's not ortho. It's not a plank. It's not split. It's not a TKL. None of the above. Numpad, ergodox. What percent are we? Keyboard types. What are like the different designations for the different types of mechanical keyboard? None of these have this information for me. I need to figure out what percentage it is. There was a good picture on Reddit a while ago. Keyboard type percentage. Full-sized, compact, 10 keyless. It's not even 10 keyless, isn't even like 75, 65, 40 numpad. It's like more than 75. It's like in the 80s. Maybe like a 75 is smaller. Is it 96? Is that what it is? 96% keyboard. Doesn't look like it. That's not what I have. I don't have a 96. That one's everything's mashed together. And a 75 is also everything mashed together. They got Ligma? Yeah, 75 is not... I mean, it is actually kind of close to 75. It looks like there's the same... No, well, there's 3 more keys. Oh, is that quesadilla going to give me heartburn? That'll be fun. That'll be fun. I'll look at chat in just a minute. Yeah, okay, so 75. That's my keyboard. This is a 75%. Okay, all right. All right, so confirmed. I don't like to read chat for that kind of stuff. Is it ANSI or ISO? I don't know what that means. I put a slash in there. Okay. Keyboard, ANSI versus, oh, there it is, ISO. These are all things that other people know that I just don't have any information on. American National Standard Institute or for the International Organization of Standardization. I don't fucking know. Size and position of the keys are different than logical layouts. QWERTY, Colmark, Dvorak, well, we don't care about that. Backslash shift keys. Many mechanical keyboard users say the keyboard layout really depends on the user, but there are benefits and advantages, blah, 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 blah. Enter key. Okay, so enter key is an upside down L shape. So we're ANSI. We're ANUS. Yeah, this is an ANUS layout because it doesn't have the L shape here. It's just got that little guy with the slash key above it. Backslash key sits above the enter key, and fingers need to stretch to reach it. The left shift key is about 50% of the size of the right shift key. That's for ISO. So yeah, this is ANUS layout. Because it's not upside down L shape. Enter key is a wide rectangle. Ow, the pointy thing. It's like puppy teeth. Left and right alt keys are the same. Yeah. Number of keys, 104 versus 105. Oh, boy. 104 keys for full-size keyboard and 87 for a standard 10 keyless. 87? 1, 5, 9, 13, 16, 17, 18, 19, 22, 3, 4, 5, 26, 7, 8, 9, 10. That's 30, 31, 32, 34, 35, 36, 39, 40, 41, 42, 43. Yeah, whatever. Okay, so we're ANSI. Whatever. I counted. Boop. Yeah, okay. ANSI. Bop. Bop. So 75 ANSI. So 14 is our choice. Oh my God. MCU. Stem cell. No. I don't think we've gotten into that kind of biohacking yet. Pico, Pro Micro RP2040. It's a RP2040, but it's a, wait, what is it in the thing that we just did? The tutorial. This is why we do tutorials. so we have this information. What is the tutorial we just did? What did you say to use? Hold on, let's go back. We have to go back. Okay, here, RP2040. We just chose RP 2040. We were role playing as 2040. Okay, so RP S R, there it is, 32. 32. Bop. Keyboard names must contain only lowercase a to z. Please enter your blah, 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 blah. Please choose a different name. I didn't like my keyboard name. Wait, I thought I didn't. So botherboard. No, all lowercase. What the? Oh. I have to go through the whole thing again. QMK, new keyboard. Name your keyboard project. Keyboard name, botherboard. All lowercase. Attribution, used for maintainer, copyright, or ever. What's your GitHub username? Work, verb, design. I don't think I need the caps on that, do I? Hold on. Does this work if I don't do capitalization? This is just for attribution. I don't know if it's going to actually update anything on my GitHub. It doesn't really have access to it, right? Yeah, lowercase works. Work, verb, design. Used for maintainer. What's your real name? Oh, bother. And then we're doing an ANUS 75. So number 14. And then we're using this guy, number 32. Created a new keyboard called Botherboard to start working on things. CD into the keyboard, Botherboard, blah, 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 blah. CD Botherboard. No such. You son of a bitch. CD keyboards. There's no tab complete. Botherboard. You son of a bitch. CD keyboards. CD, go fuck yourself. Okay, CD into keyboards, botherboard. That's what I'm doing. I think maybe there's something in the way. There's keyboards. Yeah, it's CD. We're way back. We've gone all the way back. That's why. Oh my god, I got like NT user data and stuff. This would be CD users. Oh bother. Damn it. You son of a bitch. Where the hell are we? We're in app data? Drawings. SVG drawings. Yeah, we're like an app data or something like that. Local settings, music, my documents. Yeah, hold on. I gotta find out where the hell this directory is and get us all the way back there from wherever the hell we are. It's not downloads. It would be users oh bother, yeah. Okay. CD. Keyboards. Motherboard. There we go. All right, now we're where we need to be in order to build the software. Man, that was annoying. Keyboards. A all the way down to B. Let's get the botherboard. You really got to live with all your choices. If you choose like Flumpity Blumpity as your name, you're going to have to be able to find that directory. Here's our rules. Here's our config. Okay, cool. That's why we let this thing build all that stuff for us. Has the Pi Pico been added to the QMK repo yet? I think so, but I think it instead you're just using the chip RP2040, which I think is fine. So it's not too hard. I mean, if you got it set it up the way I have it, or at least just from the tutorials, it looks like all I need to do is just play around in these folders in order to build up my keyboard, and then I hit compile, and then I drag and drop this thing into the actual micro. Why is my phone not charging? Hold on. My phone is running my pancreas, so I got to make sure that it's sitting on something that's going to charge it at least just a little bit. There it goes. Okay. What have I missed? Do you have a knob? No. I mean, physically, yes. I myself as a man. Weird enter key, yeah. That is it, indeed. Numpad. Has the Pi Pico been added? Guess it has. Blah, blah, blah. Capitals. QMK is a pain in the butt. Yeah, we figured it out. Everything has to be lowercase. I mean, not everything. It's just the name of the keyboard itself. I guess it doesn't like making uppercase folder names for some reason. But this is ready to compile once we give it a little bit of stuff. So now we can go to the Reddit thread where it is explained what we're doing. Oh my God. What we are doing with all of this stuff. And then we're going to need to go into the key maps, and we're going to need to make it work for the multiplexers, because we've gotten one button working, one row, one column. And then we need to get it working with three multiplexers. So I need to do the hardware, and then we need to hook it up to the software and see what kind of speed it has. I remember the Pico uses GBOS to run QMK. I don't remember. So that's in the future. Hold on, let me isolate this. Let me get that into its own thing and just minimize that. So OLED SSD 1306. This is one of the other pieces of the whole puzzle that we need to actually make work. After that, we'll have to figure out how we want to make the LEDs work too. But I mean, LEDs can come after everything else. Let's get this working. So we got our monochrome 128 by 32 I2C OLED display. We need 4.7K ohm resistors. Now, do I do through hole for this just for the breadboard? I guess I will. That'll be the easier way to do it. So what we'll do is we'll take 3.3 volts and ground, and we'll put it out to the rails on the board, and then I'll find some 4.7 kilo ohm resistors that we will be able to run I2C off of. See, before we get into the hardcore programming stuff, we need to do just a little bit with hardware. So let's get this thing up and running. And actually, I should probably pull up on the other screen that thing that I just closed, the pinout for the Pico Pi. So I'm going to open up that thing that I had previously opened with all them pins on it, so that I just have a guide on my other screen. There we go. Okay, pardon the burps. Okay, that, we need one of these tweezers. Helps you just manipulate things like your audience. You got to manipulate your audience. You have to have some hot political takes that you throw out into the crowd so that everybody can start getting angry at one another. I don't do that. We don't do that here. We don't do that. Let's see here. So we got to go from, we need a ground and we need VSys, which would be 3v3, but there's a specific 3v3 out. So that would be 1, 2, 3, 4, pin 5. So 1, 2, 3, 4, 5. We're not using 5 volts on things. We're going to try to use 3v3. Hopefully our multiplexers, even though they're very old, will run off of 3v3. Sorry, 1, 2, 3, 4, pin 5, 3 volts. I need to put 2 jumpers here because we're going to be tapping all kinds of different voltage levels. I don't think I like this jumper kit. I think this has 2 discombobulated of lengths for me to really utilize. That'll do. Plus to plus. Ashes to ashes. So from there, and then this one's always a little bit more awkward. You could just scooch it like that. Oh, come on. Hard to find a good jumper cable kit, you know? These wires are, I could use slightly longer ones, but these are the ones that are in between the two, like, super long wires. Whatever, good enough. Need to make like a rail for the top of that thing. Bones to bones. All right. Okay, next. 3 volt to there. We need ground to the rail. So we could do multiple, there's like 5,000 ground taps on this thing, but VBus, VSys, ground. So VBus, VSys, grounds right here. VBus, VSys, ground, 3v3 enable, and then out. I don't know what 3v3 enable's doing there, but I don't know if we need to enable it explicitly with this micro. But yeah, I should do another ground tap down here just so we have a nice stable ground. I don't want the ground to have to travel all the way around if we're doing high-speed stuff, especially on a breadboard. So the third pin, 1, 2, 3. This one is ground. 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 This one's ground. Okay, there we go. Got it. Got it. All right, so that's all hooked up. So that's that. Forever solved. No problems ever again. I2C. I see what you see. I2C. We need, what is it going to be? Ground and VCC on the left. So ground first. Just go like that. No, it's too close. Ground like that. Ground. Next one is VCC. I guess they won't get any differentiation. These short jumpers are the ones that are always get lost first in these kits. That are always get lost. The ones that you lose more often than not are the ones that make the jump out to the voltage rails. So that's ground VCC. You flip this over. So ground VCC, and then serial clock and serial data. So if we're gonna use pins 1 and 2. Hopefully that doesn't lock us out of anything. But pins 1 and 2, we're gonna send it a considerable distance too. We'll use the big long red wires, because I need to get that wire out of the way, and then I need to get it all the way to where the power is going to be. I'll send it a long distance because it's going to have to go a long distance in the final thing. So this is as close as I can get to emulating it. So which one is which? This one is clock. Clock is pin 2. And then data's pin 1. Then we need to get our 1.4K jumpers to power, their pull-ups to power, on those same pins. That's where the through-hole resistors come in handy. So I'm going to plug this in a couple rows down to give us a little bit of room to work. That's almost all hooked up. Now, for resistors, we're going to use through-holes because we don't have to make a little adapter board for through-holes on this. I'm going to try to get it out of this frickin' thing. You're not moving. You'll do this. Release the tension. There we go. Now I can get it. Blah! Through-hole resistor kits. These things grow on trees. They're very cheap. They are, yeah, they're almost one-time use. You want to get more than one use out of them, but eventually you just have to kind of give up on the kit. And they're like $10 each too, so it's not that big of a deal. It's only just wasteful. That's all. That's really the bottom line. Those are 10Ks and 1Ks, 4M7. You're getting close. Are the labels on the other side of these? Oh. It's flipped. Hold on. These are kind of tough to sort through. 1K5. It's not quite there. 56K. 3K3. 5.6. I don't see 4.7. We go directly to 3.9, which means I've probably taken out other resistors. Let's go with 3K. That'll be close enough. Near enough as makes no difference is really with the pull-up resistors for I2C. These will be a little stronger with the positive power, but the microcontroller can take the current. We'll use those, even though we're not supposed to. It's supposed to be 4.7. we go to surface mount, I'll definitely have 4.7s. So we go from 3v3 down, and I could use, I got all these cool, like, I never really had an opportunity to use this. I've used it before on camera, but where did it go? I've got this tool that I kind of keep squirreled away. Where did, I think I lost it. In here? No. Up here? Yeah, it's right here. I got this tool. This thing is weird. It's this cool little ruler, and if I wanted to make the resistors go from spot to spot, I can just go hole to hole. So I want it to go to positive, and I want it to go to this one right here, lock it down, and now I can just put the chip resistor, or put the resistor in here, bend the leads down, and then clip them down here. I don't know why I don't use this more. It's a very cute little tool. And now I've got an exact resistor jumper to go from that point to the positive rail. Now it needs to go over stuff, so it's going to be a little bit sloppy, but well, I guess what I could do is I could put the resistors down and then plug in the wires. Because yeah, that'll just go... Oh, there's a gap right there, of course. Of course there's a gap right there, so I can't quite plug it in that way. I'll just do it a little crossways. That makes a nice clean resistor. Yeah, there's all kinds of stuff you can print in order to make this I found at like the bottom of a drawer. Might actually belong to the FBI. I don't know, but anyway, this I found at the bottom of a drawer. There's all kinds of little helper tools like this. People love either designing them for 3D printing or, you know, in the before 3D printing times, just every kind of like little kitschy Radio Shack kind of tool that you could find. People made. They would sell them. So there are our pull-up resistors. Now I got to get these wired again. So the second the jumper wires that I bought, they're a little thin. They're actually not they're not sticking in well in these holes. I got to be careful about them. Pin 1 is SDA. SDA is the one on the edge. So pin 1, one on the edge. Clock is the one in from that. Double check, flip, ground to ground. Okay, good. So that will go right there. There is our hardware for the screen finally implemented, and it took looking it up and finding somebody else who had done this as their own custom project. It's just, I have a problem with software. I keep losing beard. I keep scratching my beard and like pulling at it and losing beard hairs. I don't know why I'm doing that. This is the thing that bugs me about these big sort of extensive software projects is they've made all these tools that do the work for you, right? They make it easy for you to configure and just use commands in order to compile exactly the right keyboard. And then they have this project that is like so universal that you can use all these different processors to make your stuff work. I work on a lower level than that. I want to know what the pins are for things because we are working from a low level on this specific project. So all the resources that I found were going at the high level, like here's how you reflash this keyboard or that keyboard with stuff, and they don't talk about the low level hardware, even though we know we get like pieces of information about the low level hardware. How many rows and columns is it? What's this? What does this interface with? But we need to set all that stuff in the configurer. It turns out it would have been much easier for me to look up like a custom built mechanical keyboard guide first. But we are finding the resources we need. QMK is universal enough that we're able to find all the solutions to all of these weird problems that I'm suddenly running into, like the fact that the screen tutorial says put the screen in and say I've got a screen and then press enter and it works. But that's not really the case. Is that we need to actually tell it what buttons or what pins it needs to communicate with I2C on. So it's weird like that. So anyway, looking for an L bracket yesterday, digging through some old stuff, found a box full of cords, power adapters that my dad had, was kind of pumped about it because this old odd size USB chargers. Oh, weird. Yeah, I don't know. I've thrown away a lot of cables recently, so naturally I'm probably going to do a like a Windows 95 project and end up needing like a VGA cable or something. You know how that works. As soon as you throw stuff away, you're going to need those parts. Oh, boy. I need like trim over here. I don't know what's going on. Ugh. Okay, anyway. Sorry, I'm looking. It's like looking in a mirror. There's our pinouts. Our tutorial. Hold on. Bring that over here. And bring this to this scene. It's going to cause an infinite. Blah, 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 blah. Okay, so, yeah, those are pinouts. We are on this, the person who's telling us how to wire this thing up. So you need to identify SDA and SCL pins on your controller, as these will be used by I2C for the controller to communicate with the display. Choose GPIO for the pin for the reset. We already have a reset, a built-in reset button. Add pull-up resistors. We did that. Hook up SDA to SCL. Got it. We have a 3v3 controller. Wiring. Yeah, there's a wow. Okay, setting up the firmware. Take a look at Wes's support total here for his IOTA keyboard here. Page not found. Perfect. How old is this? 5 years ago. Oh, boy. 5 years. Oh. Now, is support for this already implemented? We might not have to do exactly all this stuff. We just need to get to where greater than 10 for what? Oh, SSD 1360C. So we need to look up QMK add screen. Is this the same one? This is the same one. I need a more updated tutorial, I think. Oops, I closed the, hold on, let me get that page back. Let me get my search back. Yeah, like this is Z-vector feature, OLED driver, docs. So how do I add QMK add feature to keyboard command? I think we do this through the command line, at least initially. I need like a tutorial for this. Configuring QMK. Key map and see. Hold on. What's this program called again? MSys. QMK MSys add feature. Now, back. There's got to be a way that I can like use a command in order to add a feature to my keyboard. Maybe add screen to keyboard. Well, getting started isn't helping me. QMK tutorial will walk you through creating a key map. We're not there yet. We're not quite there yet because we gotta go a little deeper into the system in order to get the multiplexers to work. Building firmware, you can configure firmware. Configure your build environment to set the defaults to make working with QMK less tedious. You can also set your default key map name. Most people use their GitHub username as the key map for previous steps. User key map GitHub username. You just received some of these LEDs in the mail. Jeez, I hope this works. I mean, we're gonna need a key map eventually, so I might as well just follow this thing. So QMK new key map, and then you want to create a copy of the default key map. If you configure your build environment in the last step, you do that easily. QMK new key map. If you did not commit, I think we just do new key map. Oh, thank goodness. Bother. Oh, bother. Does it take underscores? Let's find out. I think it liked it. Oh, bother key map directory created. Compile a firmware with your new key map by typing, yeah, keyboard, bother board, key map, oh, bother. Now we need like a screen. Open key map in your favorite text editor. Customize the layout to your liking. So we're gonna, when we do this with keymap.c, we're gonna need to build in the scanning. We're gonna need to build in the row line scanning by setting outputs, which will be kind of weird and interesting. But yeah, we'll have to see. When editing your key map, don't add commas. Customize the layout to your liking. Build your firmware. Flash your firmware. Screen. Driver install. You really need Z dialog? I don't think we needed Z dialog. It was typing keys like immediately. It would be more interesting if I had like something TurboNAD, like what TurboNAD's working on. If my keyboard had a bunch of like physical gauges on it, and then I'd have to incorporate some kind of a back and forth driver communication stuff. He's building a lot of simulator stuff in his setup. Key codes, software features. No. Hardware features, displays. Which one were we? OLED. But this one has us adding stuff to the rules. I want to be able to do this in... I want to be able to do this within the command line so that it can set it up for me automatically. Basic configuration. These configuration options should be put in an example of that. So these would be the configuration values. Do I have to do all this stuff in order to get it working? LED rotation. And then there's the API. Hot damn. I just want to make it work. Oh my God. So let's see. Helix and logo. It doesn't look like you can set up the OLED from the command. Huh? Hold on. QMK MSys OLED command. I don't know. Recently discovered Pet Luna post 2 years ago. We're moving forward in time a little bit with these Reddit threads. Recently discovered the Pet Luna post. Wanted to add that my old OLED screen, but this is the first time doing something like that. I've never traversed GitHub, so I don't know if the directions are included. Very minimal Python code experience. The only thing to know. QMK is to make a key map, download the hex file, and apply that for Flash. Any advice on input tutorial? Okay, sounds like you're using the online configuration. And then, of course, the new layout is such dog shit that it tries to, oh, we'll keep them on their site if we don't show them the full discussion. I hate the new layout. Hold on. Let's make that an old Reddit. Oh, that's so much better. Oh, look, all our information is right here that we were looking for. And this can go away. Okay, configurator. Start with building a QMK environment for your computer. You don't actually need to know the blah, 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 blah. Once you set it up, you want to use your file explorer, QMK's make command. I don't have a board with an OLED. I haven't played with them. So you don't know what you're talking about. Thank you. Afraid that after going... I mean, this is what we just did. We just did all this stuff. So now we're in the part where the guy just says, I don't know what I'm doing. So let's see if somebody else has jumped in. MSys2. All this complication, right? QMK MSys. All you should need to do is open MSys shortcut. Okay, so they're walking them through this. Yeah, they tried. They're all copying off of each other, and they don't know what. Especially with Reddit. I mean, Reddit does know what made it a good site. It was the simplicity of the UI and the ability to parse information very quickly as a user. But not everybody's looking for that. Some people are looking for social media. And so we get social media layouts from other successful social media, but it's a discombobulated amalgamation of all the different features. And so it becomes this it becomes like the Fisher-Price, like jungle gym with all the soft edges and stuff. And you end up losing features to all of the bumpers in the bumper pool. edit key map file, which is your C code, in order to turn that key map into a hex flash. Yeah, so this is just, nobody's covered LCDs in this post, or OLED. How do I customize my OLED screen? Well, first you need to make your custom key map, and I guess the key map is what defines the custom OLED, but I'm looking to see if there's just like a command line input that will import this stuff. And it appears like there isn't, but they keep referencing like drivers and stuff. And I'm wondering if I need to, I don't want to have to import the drivers myself. I want the software to do it. I want the software to do that. That's the whole point of the software. OLED features, 2 steps. When compiling a keyboard, you need to add the following to your rules MK. OLED enable, yes. Then in your key map, implement the task call. There's an example for putting up a logo task. Default font files, so you need a font. Drivers, OLED, GLCD font. There's a buffer. For some purposes, you may need to read the current state of the OLED display buffer. These configuration options should be placed in... Okay, you'll need to do 2 things. First, you'll need to enable OLED, right? Second, you'll need a call in your key map. Also, you need to put these configuration examples in the thing. That's not 2 things, that's 3 things. I guess it's default otherwise, but damn it. That's for custom size, that's for 90-degree rotation. And then there's the API. There's all the stuff you need in order to program LCD functionality. I don't know what I'm gonna do with the LCD, by the way. I don't know. I just want like a status. I want to know what's going on. I think it would be cool. But all right, okay. OLED driver, SSD 1306. So we just need these 2 in there. Kicks per minute. Could be give me some my survival meters on my summer car. So there's no way to just import all of these options into the thing so that I can quickly get this to build. I think that's a little weird, right? Shouldn't there be QMK MSys OLED import command? Old Reddit look plugin. Oh, so you can get it to always look like that. I mean, I use Res, so I don't know. If they disable old and pay Reddit, I don't know what I'm gonna do, because Reddit is one of the greatest consumer review tools that exists. Amazon could have been. They decided not to go with that. Missing MSys import. Okay, can we not? RP2040, QMK on RP2040. How do you do the screen? Yeah, they just have their UF2 file. There's no source. KM default, new UF2. Full list of key codes and key maps, mute, etc. Macro pad. Firmware for the macro pad. That's the key map, encoder map, progmem keycaps. There's no screen implemented on that. Yeah, layers and key maps, assembly instructions. Gherkin, it's a pickle. That's flashing that. Default key map with QMK. Configurator, which I'm not going to be using, and then QMK firmware, place out similar to that. I'm looking to see if like where 1 key keyboard with OLED. There we go. That's what we should have been originally looking for. STEMMA QT. Connecting OLED displays. This is supported by QMK. Well, I didn't end up getting that, but whatever. Make it even easier. The author of this guide also contributed a pull request to provide easy-to-use example of the KB2040. Aha! That's what we've been looking for. D3D4, cable to blah, blah, blah. So we're just going to, like, steal their code. The build steps similar to the other firmware followed in this guide. The keyboard is a hardwired one-key KB2040. Note it's now KB and not RP to indicate the use of KB40, 2040s, Stemma, QT. This is just another language. This is just like getting away from, this is what happens when you jump into a forum and you haven't been properly initiated. Blocking Reddit entirely works well too. I mean, I just use old Reddit and I use it for specific purposes, like dopamine late at night. Key map is OLED. Steps only work when you fetch the pull request from GitHub. Using the commands shown below, it's easiest to just grab the UF2 above. Huh? OLED. So git fetch origin merge fetch head flash KB hardwired 1K KB40 key map is OLED. So it's part of the key map. So we're going to be modifying our key map. So that's not, I guess that's why we don't have like an import command for this. It would be nice if we did though, if it would at least set us up like initially. Rather than working as a keyboard, the one button is used to control the demo. Click the button, short time to switch the mode. Hold down the button to rotate the display by 90-degree increment. After a short time, OLED display will be set to all black to prevent burn-in. So the thing is, like, this is for their hardware, and we're not using their hardware. So I don't think I'm gonna import their tutorial because we don't know what pins those specific things are. We don't know what pins that header uses. I mean, we could look it up. We could look it up and we could wire the board that I have directly like that. But maybe we could just get a logo to present on that thing. Because this is how Adafruit teaches you. They show you the bare minimum. CD1 define. So config.h, the following settings are needed. When was this demo made? Because this is a little separate from what the Reddit one says. This one says, well, they're following somebody else's. So they need these three: GLCD font, I2C master, TWI master, and SSD 1306, which it should be in the drivers folder. This is confusing. I'm trying. This is firmware, drivers, OLED. And then in here we've got, yeah, so that's already in there. It's already in the drivers folder. So that's already all in there. Okay. Where are we? Going back a little bit. Keyboards. We are in keyboards. I think it was botherboard. Yeah. So key maps and config. Uh-oh. No. Don't. Nope. Open with Notepad. Whoa, look at that. That's pretty cool looking. Damn. How the hell did you guys do that? Shit. That is not at all what it's going to end up looking like, though. I think maybe our layout needs to be custom and not this. I think maybe I need to do a custom matrix because rows and columns on this thing, this is not how this works. And it's got a fixed number for all this stuff. Oh, that's pretty cool, though. I like how they have a whole picture for it. Well, that's going away. Ba-da-ba-ba-da. Let's delete that. And let's put in, we're gonna go back on the commands. New key map. Key map name. Oh, bother. Oh, did it just chose that? We didn't even choose which one it was? Where do we actually choose the key map? I think that's when we did the keyboard type. Yeah, probably should have been none of the above. All right, I'll have to look it up because this will just make it again. Nope. Yeah, that'll just make it again. Made the exact same thing again. What's the difference between old and new Reddit? It's they pack stuff around to like display differently, and they want it to be more of a permanent scrolling social media instead of what I have on my other computers. That my default view is like no preview images or anything. It's just title, 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 and it's very compact. And then if I want to expand stuff, I can expand stuff. If I want to go into the comments, I can go into the comments. It's just a different way of you know, consuming the media. It's an older school way. Instead of it being like a doom scroll where all the videos automatically play and stuff. Yeah, this is tough because these are indeed all of the keys that I have, but they are not going to be laid out so cleanly. They are not so cleanly laid out, and we will have to figure out how exactly that's going to work. This is going to be the challenge. Rows and columns. Or maybe it stays like this, and there's some other define that I need to put in there. But anyway, here's our keymap.c. So let's just get the screen working right now. We don't have any definition of that stuff, so let's go to the more modern one, I guess. Wait, what is this one? Oh, this is their add KB one key keyboard, works with the LED key map. That's not what we're looking at. This one. So Qt stemma Qt configuration. The following settings are needed. The appropriate config.h file. Use the I2C. So let's go and get the config.h file. There's a lot of stuff to learn suddenly. A lot of stuff to learn. Okay, so we've got pragma once. I don't know what the hell that is. But then we need to add. So I'll do feature disable options. These are options also used for firmware size reduction. So let's do this, and do OLED section. We define all that stuff. Wait, what? Pragma once, but I've got that already in here. That's in config.h. Sometimes, man, I tell you, Adafruit does stuff a little bit weird. If your board has a different pinout, first determine GP, GPIO number. Okay, GP 12 and 13, it's actually GP... Bop, 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 bop. Where is it? Where's my layout? Oh yeah, MS Paint. Bonk. We're actually using GP 0 and 1. 0 is SDA. 0, 1. And the I2C driver, I2CD1, I think that's correct. Huh? Wait a minute. Undef. Why are we undef and defing? I2C, so we're activating I2C 0. We're not activating I2C 1. Huh. Your board is a different pinout. First determine GP, GPIO number of the pins instead of GP 12 and 13 in config.h for SDA pin and SCL pin. Then determine whether they're on I2C peripheral 0 or 1. Okay, so we got that. According to the pinout of the RP2040, and set the appropriate use I2C line to true. Okay, so we're taking this and we're going to MCU configuration.h. All right. Jeez. mkuconf. Bonk. Bonk. No. Let's close that. No, we don't need that. MCU conf. Uh-huh. Really? So I need to go all the way into the MCU configuration in another folder, or do I not have the right MCU conf in here? That's the question now. Because I feel like I shouldn't have to jump out of this folder in order to do... No, okay, so we need this file, mcuconf.h. It's not in here yet. mcuconf.h. All right, pragma once, all that stuff. Now let me just check with another file. Use DMA, false. Yeah, okay, cool. So we don't need much on this. Wish I had this kind of tutorial when I built my keyboard with the Teensy 3.5. You don't really, I mean, the Teensy, the way it, I don't know about doing it like this. When I was doing, like, for instance, like Octopedal and stuff like that, like, it's like the Teensy system is so easy because you just choose keyboard from the pull down. Right, you just choose keyboard from the pull down, and then everything else is done on a low level. I feel like I'd have an easier time with the Teensy doing what I'm doing right now. But I'm expanding my capabilities. I'm getting into new horizons here by programming stuff. All right, so there's all those. We've got I2C bank 0, which is correct. RP12C, or sorry, RPI2C. I don't know if that's what we should be using, because they're using, their board is RP. Ours is R something or other different. Where is that? Hold on. 20, 40. It's all these little, oh God, all these little things that are like little roadblocks that you have to sort out. Where did the OLED part go? D3 and D4 OLED. The steps similar to the other firmware we found in the guide: keyboard hardwire 1 key KB2040. Note it's now KB2040 and not RP2040 to indicate the use of the KB2040 stem EQ. So it is RP. Okay, so we got it. Yeah, the Teensy is incredibly expensive compared to the Pro Pico, whatever. That's what I mean. I've got a 3.6 sitting in the bin, and that might have been our backup because the number of rows and columns was a full 26 pins, and so we had no room for LEDs, and we had no room for like I2C. Now I could have done, no, I can't do the LED control on a port expander because the port expander doesn't support PWM. We can't give it a command to set a PWM, which is very unfortunate. So we're going to have a PWM engine running for the backlighting directly from the microcontroller, which means I need 6 pins plus I2C plus all the pins for the rows and the columns, which is why we're going to be using muxes. So we're going to get into hardware in a little bit. I just want to make sure that the screen can work with everything else. I want to get the full system running so that we're punching I2C out, we're punching LEDs out, and we're reading all of the muxed keys. I want to see that whole system come to fruition. So this is going to take us a little bit, but we're getting through it. I'm getting closer and closer. The board has a different pinout determined, blah, blah, blah. QMK numbers the I2C peripherals very differently when it comes to defining the I2C driver. So add 1. I2C0 is I2CD1. and I2C is I2CD2. The fuck? What? You can use any appropriate pair of pins that are capable of I2C in the RP2040. Hi? Egg 1, I2C is I2C0. Defining the I2C driver, so add 1, I2C0 is I2CD1. I don't know what this means. To enable the I2C driver and the OLED display, you place lines in the rules.mk. Okay, rules.mk. This is a lot, and I think the best thing that you can do is try to stick to a singular tutorial. The problem is we're modifying the tutorial because, you know, there's never something exactly applying to exactly what you're doing. This is like using Linux where you run into a problem and nothing is quite exactly what you're doing, but they all kind of revolve around what you're doing. They all kind of sort of skirt the functionality. They all get close. And so you find yourself following 4 different tutorials. So I'm limiting myself to the Adafruit tutorial now. We are lightly modifying the Adafruit tutorial because it's skirt, because it's slightly close to what we're doing. That's our layout. Holy shit. This is, I may need to define a new layout or whatever and have it not be a 75 and instead just make our own custom. Even though it is a 75, they seem to expect it to be nice and neat and organized, but yeah, I always end up with all the things installed for the first half of 4 tutorials, then choose a completely different route to complete it. Yeah, as your knowledge base builds, you start to realize how unapplicable all the tutorials are. I'm gonna let me take a heartburn med so I can continue to yell at you guys, because we're gonna be here for a little bit today. I don't suspect this one's gonna, that means the puppy's gonna be riled up. At some point I'll get her down here and you guys will be able to see the dog, but I don't have, I don't trust her down here yet. She's too young and she can't get upstairs on her own, so. I mean, I can write my own firmware. That's what the Teensy would let me do. All right. Yeah, she's too teeny tiny. She's too teeny tiny and too cute. I would love to have a puppy stream, but this isn't a puppy environment. And then someday, maybe in a year or 2, she'll be able to have a bed down here and she can just hang out while we do this stuff. You know, and maybe we'll get visits. Maybe we'll have a little puppy visit every now and then. That would be nice. Edit with Notepad++. Here are our rules. Oh my God. Boot magic, why not? Mouse key. I don't really want that, but whatever. Extra key, don't care. No backlight yet. RGB light, not yet. Audio enabled, not yet. Encoder enabled, no. Okay, next. Yeah. That was my most aggravating test in high school, was where the last question was well, the first instruction was read all instructions, and then the last instruction is sit quietly and wait for everything to be done. You don't have to do the rest of the questions. And so the people furiously working and the people just sitting around going, I got the trick and you didn't. Shut the fuck. God damn it. All right. Anyway, rules.mk. Rules MK. OLED enabled, yes. SSD 1306, that's what we're using. Opt defs plus doll use. Oh, huh? What? What does that even mean? Why is that necessary? And of course, Adafruit doesn't explain it. And maybe they do. Hold on. Let me check. The function OLED task user contains code to actually draw to the screen. The OLED example, this is there. True, and the other false. MUconf, MCUconf. QMK numbers the I2C peripherals differently. What is this? dhall use I2C is equal to true. For opt defs. I know. I just don't like when there's stuff in there that they don't explain. These are self-explanatory. It's why do we have a plus equals and then negative doll use I to C is equal to true? What the and there's another equal sign in there. This defies. All right, whatever. Keyboards, hand-wired, one key maps, OLED key map. The code can draw letters or work by individual pixels. For full info, check out the documentation. So they're adding this. If it's getting screamed by law, you need to play Doom on it. I don't even know how I'd start. I'm not a computer engineer. I don't even know how I'd start that. It probably has been done because this, I think, is the screen that they put in that pregnancy test. I think this is the same screen where they ran HDMI to this screen and they put it in a pregnancy test and they said, this pregnancy test is running Doom. It's not. It's not running Doom. Test characters void, columns, rows, OLED max characters, max lines, bool invert false. So we're not doing anything with the settings file. Not invert columns and all that stuff. So this would be in the key map, which is over here. We have an if-def. Well, we don't necessarily need the if-def, but I'd like to have it in there in case I want to disable it, which means I go all the way back to the Reddit thread, which is tutorial number 2. Or not. Hold on. No, that was the from this. Oh my God, we don't need this. If def OLED enable. There we go. That's just what I wanted, just in case I don't want an OLED. Pop. Then end the if right there. That ends the statement. And then that would show you the layer. This one is a render logo. Let's put the render logo. I don't know what Adafruit's up to, and I don't trust them. So let's just put the render logo in there. Because they're doing test characters. Well, maybe we want that. Yeah, I'll leave that. I'll leave that in there right now. And I can do this, but I'll comment it out. Really? Okay. Comment it out. I can't. Is it shift? No. Control / no. I'll just right click. Comment. Oh, it just does that kind of. All right. It's no Arduino ID. I'll give it that. Save. Now we compile. Yeah, it needs a yay sliding across. It would be monochrome, but I could probably pull it off. I'll have to find out what I want to do with the screen. I just wanted it in there just for fancies, you know, just so it looked cool. But I think that's what we need. I mean, we're at the bottom of the Adafruit tutorial, so let's try to compile all this crap and see what we can come up with. How do we compile again? KB is botherboard. I mean, we're already in the botherboard folder, and the key map is oh bother. QMK flash, keyboard botherboard, key map oh bother. I think that's all we need to do, right? Oh, look, they even told me that that's what I needed to run up here. I'm smart. Let's hit enter. Do I need to tell it anything else? Like I want it to be in RP2040? That's the only one that it has. So it only has one processor that it can use. Yeah, if you could just like choose an emote based on what I'm typing. And just display that emote on the screen. I mux. I demux. I mux again. Making bother board with key map and target flash. It's taking forever. It takes a long time, I guess. This is like the definition of bloat. There are a lot of keyboards out there, and they're all very different from one another. But this is an interesting system. You know, it is relatively easy for somebody who doesn't have all the low-level stuff, and it seems to be like it's kind of easy to cobble together a bunch of different like components in order to make a universal system. It's sort of Legoizing keyboard stuff. Just the compiling is a little bit excruciating right now. Jobs equal 1? What are you, huh? What does that even mean? This is not moving at all. Oh, this is the number of parallel processes. I see. How many did it do originally? I mean, when it did jobs is equal to, like, it flashed before and it was jobs equal to 1, wasn't it? 2 by 1 millimeter bearing spacer. What? Task manager? Nah, it's okay. We'll just let this thing go. It'll get there. There it goes. It's free software. There's no warranty, etc., 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 etc. This seems slower than before. Oh, I also don't know where those keys mapped to in terms of microcontroller pins. I don't know what's going on there. Uh-oh. Error 1. Matrix column pins. Yeah, we didn't set the number of pins. No resident sleeper. It's too cancerous. I don't want people coming in here and making fun of the games that I like to play. Even though we haven't done games in a little while. All warnings being treated as error. Platforms, GBI. How am I going to be toxic? I don't know. You figure it out. You're good at that kind of stuff. I think it's because we didn't define any of our pins. Yeah, matrix column pins C2, C2, C2. So how do I turn it into something that's going to let me just like proceed with building this? If I make a new layout and I cancel out, but the problem, VIA, wait, what's VIA doing in here? Oh, because we're in box 75 keyboards, and we're in bother board. Yeah, I would like to get back to my summer car. I want to win that rally. Can I, let's see, comment this out? Something? I mean, if I start with a new one, let's just do like, let's do a new keyboard. Name your keyboard project. Screen OLED test. OLED test. GitHub. Real name. Borb. No, we won't blame that one on Borb. Blimby. That's my real name. None of the above. And then 32. What do you mean keyboard names must only contain 80? That's what I did. Oh, I did a capitalization. OLED test, all lowercase. It's hard to do. Use for your GitHub. Design. Real name, Blimby. Blimbo. None of the above. 32. And CD OLED test. CD dot dot. CD. Well, now nothing's going to be in there. CD. Yeah, we've gone way too far back. God damn it. Stupid interface crap. Boston meetup. Ugh. Let's see. We are looking for OLED test. JKLMNO. This is kind of clunky, isn't it? Maybe if I knew what I was doing with the command line, it would be a little bit more smooth. OLED test. There it is. We'll just CD into that. CD's nuts. CD into that. And we got, for some reason, it changed the colon to a slash. And now we're in the directory, so we can compile. Now I need to take some of the stuff from Botherboard. We need to transfer it into this project. This is just so we can avoid the key mapping error. So I need mu, I'll take rules, and then the key maps, and we'll take config too. Copy, and then, well, actually, I need to see, does config have anything about the key map in it? Did I fully close Notepad++? Jesus. OLED test. KLMNO. Oh yeah, that just says Pragma 1. So yeah, we'll just replace it with these files. Yeah, because that we'll just add this. So paste, replace. That's everybody. The key map, there's nothing but default. Default key maps. Open with Notepad. So it's gonna want this. Well, I don't know what we can do about that. Let's look at a functional one. All right. Let's look at a functional one and see what we got. Is the hand-wired one key. We'll just take that. Key matrix, row column, debounce. Yeah, we'll take all this stuff and put it into our OLED tests, so that way we have, let me actually close all these so I'm not editing the wrong files. You go all the way back to OLED test. I just like, we just gotta make a non-keyboard keyboard. This isn't hand-wired. I should open this up in another folder. I do this stuff a lot faster when I'm not on stream. Right now, I am under the I'm under the gun. I got to explain absolutely everything that I'm doing, every single thought that rattles its way into my head. OLED test. We're gonna open that in a new window. And now I can go to my config. And now instead of all this stuff being like that, we'll just fire all the other stuff into it there. And now I've got all our stuff. This is all we need to run one button. So rows, columns, diode direction, column to row, define to bounce. That's all the stuff we need. We're going to need that in our later config anyway, too. So that's config. So now let's go to the, what was it called again? Hand-wired. Hand-wired. One key. One, that's config. one key.h. What does that have? Pragma wants define layout ortho 1x1. So whatever one defines that keyboard, which is going to be, where's my other folder? This one. But there isn't a one key.h. There's just MCU conf and config, and then a key map. Should I do like a just copy and paste this thing over? Weird. Paste. Are there any rules? Oh, what is that even opening in? .mk. Oh god, it opened in... I don't want this. Wait, why is there an OLED driver? Oh, because we edited that file before. Well, that's never gonna work. Copy. Paste. Paste and replace. Yeah, so now we have layout ortho 1x1, and then OLED drivers SSD 1306. Default folder, that's wrong. That's going to be N-wired 1 key Pico micro. Why is that? Oh, I see. That's why it has a different one. Let's get that out of here, I guess. What does our other one have? The bother board. I'm referencing too many things. I'm going to get confused and it's not going to work. Bother board? Oh, that's in hand wired. Bother board. AB. Balloon dog. What? Botherboard, botherboard, botherboard. Bastard keyboard. Oh, they took my good name. I would have named it that. BLBO. Bob pad. Board run. Boston. There it is. And then I'm looking at rules. Oh god, it opened in that again. Oh, there's literally nothing in rules for this. Okay. Huh. Okay. Weird. Wait, I thought that was populated. I thought that was... Okay, well, we won't question it. So yeah, for this one, this is the single button keyboard. So let's see. OLED driver, SSD 1306, layouts ortho 1x1. OLED enabled, yes. So everything we need is in there. Default directory, I didn't change. I'm deleting it. I don't know what needs to go there because the default directory for this, for the single key, is supposed to be maintained over a bunch of different microcontrollers. So I don't know if we need that in there. I think maybe just the default will just be whatever's in the folder. Keyboards. Hand wired. And then we're looking at the one key example. Yeah, these are built so that you could put them on a bunch of different things, a bunch of different processors and stuff. Layout, key maps. What? Why are there all these different key maps? Haptic OLED. There's a whole key map in here. Modes between test first and test last can be switched. Huh. Okay, maybe we want to take this file. I think we want to take this as our key map. Oh my god, look at all this stuff. This is like an extensive test. There's a lot of good stuff in here, actually. All right, let's steal this. Keymap.c. Copy. And then in our keyboard, our OLED test board, and our key maps. No, not shortcut, you stupid. Paste. Or it shouldn't be, it should be in, why does this get its own rules? Hold on. Wait. Ah, damn it, wrong. Tap dance enable. Those tap dance enable. All right, well, tap dance enable. Rules. No, this is the wrong. I don't want to edit it in that. Tap dance enable. Equals very yes. Okay, so that's rules. We need to give it a key map name, right? Yeah, it needs to be in a thing. I guess we'll make an OLED folder. So key map will equal OLED. And then we've got our rules. We have the onekey.h. Thank you guys for the follows. Appreciate it. We've got the onekey.h. We've got the MCU configuration in here with the right pins and the enables on the right things. And then our config.h has all the stuff so that we don't get errors about not having lacks anti-ghosting diodes. Well, we have anti-ghosting diodes. Okay, I think we got all the files that we need. That was complicated, and I'm sorry that I didn't have a clearer impression of exactly what I was doing, but we were basically taking the amalgamation of a bunch of different files that would get us to where the tutorial wanted us to be, which is with all of the appropriate files and folders in the right places. And it seems like this stuff is very configurable and sort of reconfigurable. You can have basically any of these files load as defaults and then get overwritten by stuff in folders if you define different things in folders. And so what I've discovered are different features that appear to be in the tutorials that I wanted to steal for our own configuration that's not going to have all of the additional complexity of having to be able to be configurable on multiple different processors at once. We just have the one processor. We want to make it work on this one. So I've been unpacking some of the stuff that's in some of the other versions of keyboards that have this feature. So what we're going to do is our keyboard is going to be OLED test and our key map is going to be OLED. So up, 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 flash, keyboard, OLED test, key map, OLED. There's a trackball mouse that runs QMK. That's pretty funny, actually. Is it that Logitech thing? Yeah, this is like, I mean, this is powerful if you don't want to do the low-level programming. And it is nice to have all this stuff here as examples of what you can do. I still have jobs equal to 1. Like if you, for instance, had, oh no! Claims to support. It's called Ploopy? What the? Wow. What did I do? This is a lot of red text. How did I mess up? Who magic is specified in both info.json and rules MK. The rules MK value wins. No, not. I guess this stuff. Did they want me to put it in rules or did they want me to put it in? Hold on. Where is the add a fruit tutorial? Where do they want me to put it? They didn't specify. OLED enabled driver and opt defs are there. So, oh, we didn't put in the opt defs thing. Wondering if I got confused and put stuff into the wrong. Doll use I2C. I don't even know what that means. But I guess we don't need this. So that's rules. Config. Now that stuff, wait a minute, huh? Hold on a minute. 1 second. Feature boot magic is specified in both info.json and rules.mk. Oh, okay. So that's what rules is doing. Yeah. OLED test claims no support community layout ortho 1x1, but no layout ortho 1x1 macro found. All right, so let's take a look at the one key, and then we want to look at what is this? What is it? Community layout ortho 1x1, but no layout ortho 1x1. Layout ortho 1x1. That would be. I don't think it's in the one key.h. Pragma once, include quantum 8. Define layout ortho 1x1. Okay, so this needs to be in my OLED test.h. Oh, yeah. We didn't have an OLED test.h. That might have been part of it. Okay, yeah, so that's all there. It just wasn't renamed in OLED test. So, okay, so there's that. OLED test matrix rows is inconsistent with the size of matrix rows 4. It's not equal to 1. Matrix row pins 4. Huh? MCU configure, Pragma once, all that stuff. Good to go. I2C1, GPIO 0 and 1. This is from config.h from OLED test. Rows 1, columns 1. GPIO. Rules.mk, ortho 1x1. Use I2C. That's okay. Where are those pins being defined? Are these like defaults of a different file? Okay, hold on. One key.c, readme text, rules mk, and then config h, and then over here we've got RP2040 with a different rules set. Hold on. Ah, damn it, why did I do that? Aha, MCU name, bootloader. Copy that. Let's put that into our rules. And let's actually edit with Notepad. I don't know about the info JSON. And then this config H has, yeah, here we go. And I need this. This is the good shit right there. That's the important shit. So into this one. No, sorry, into this one. So we got column to row, debounce 5, blah, 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 blah. OLED section, MCU section. Yeah, right now, this is just what we got right now. Okay, so I think that might round it out. I think that might give us all the stuff that we need, hopefully. Debug matrix scan rate and all that stuff. Okay, let's try it. Let's see what errors we can come up with now. What new and wonderful errors are we going to get this time? I'll get this screen working. Come on, baby. Those are all yellow. EMAC OLED, target is flash. Good so far. This will become the basis by which we can build, damn it. Make finished with errors. Error 1. Keyboard layouts.h. Object, wait, what? OLED test source layouts.h. Error 1. OLED flash error 1. There's no information about the error that I got. These are just overrides, right? Matrix pins are specified in both info.json and config.h. The config.h values win. Making OLED test key map flash. There's no warranty, blah, blah, blah. Yeah, let's look at the directory. Don't think so. Manufacturer, Blimbo. Yeah, why are there 4 specified here in matrix pins? That shouldn't be what's going on. Layout, ortho 4x4. That shouldn't be the case. Where's that defined? Is that info.json? Is that because I put a wrong thing in there? Ortho 4x4. Yeah, the default is wrong. Let's get the default out of here. I think that's what's going on. What does this one have for default? There is no default. No. Key maps. Yeah, see, it's got a different... Oops, no. I just want this. Copy. No, I wanted that. Notepad back. So this would be keymap.c from default. So we want to go to OLED test default, edit this one. No, I don't want to edit it with edit with Notepad++, jerk. I just copied it. Copy. Paste. Save. Close the key map. Close that key map. Let's look at the OLED key map. QMK keyboard H. Tap dances OLED. Static enumerator. Void this, void that. Do this, do that. Where is our... Draw the logo. Progmem carefill. Void test frame. Test character count. Slow update. Rotation, OLED task. Keyboard post init user. Debug enable true. Well, we didn't want it to... I don't know what the hell tap dance is, but there's nothing about the layout. I don't know. I don't know. Maybe that, I don't know if that would fix it or not, putting something in the default. We're not compiling it as default. We're compiling it as OLED. Warning tests, haptic, hardware ID, joystick. I don't know what we need to do. Reboot. Yeah, see, that just puts it into quick reboot. QMK, yeah, constant uint progmem keycaps. Where's progmem keycaps? Control F. Oh, what is this? No, that's OLED matrix size. Key maps. Rows, columns. Layout 1 by 1. TD, TD, OLED. Ortho 1 by 1. What do we have? Ortho 1 by 1, but oh, I see. This is overriding it as tap dance, which is weird. It's a little weird. It won't type the letter A. I don't know. I don't know if the editing the default fixed it, because this should work fine. I just don't get why the info.json has. Let's look at the info.json here. Yeah, so we need layout ortho 1 by 1, x0, y0. Let's take that. Go to this info. Matrix pins. This doesn't have anything about matrix pins in it. Versions, feeds, etc. Vid 0x0, device version 1, layout. Should I just take this whole thing and just put it into there? Because there's only one button. Well, there's a layout, first of all. That's something that we want. And then I don't think we mess with anything. Well, okay, hold on. This layout. That layout. Device version and all that stuff. And then matrix pins, I think we can just get rid of. I don't even know if that's going to be necessary. This might just be information. So it might be just that I'm not really editing anything. Crediting with edit in it. Save that. Close that. Close that. Close that. Yeah, unless it's like defined somewhere else. But I mean, we've got matrix rows and column rows here. Here's our I2C. And then down here we have GP 8 and 9. So we're not really hinting that we need RGB DI pin A1. We don't need that. Which one is which? This one's the OLED test. This one is one key. This one is rules from OLED test. And this is where we do all of our rules. Ortho 1 by 1. Yeah, that should, okay. Well, let's see if we actually did anything. I don't know if we did anything. I don't really know if we did anything. We'll see. We'll see what it does. I gotta stand up. Okay, so there's all that stuff. Which is fine. It's just telling us that it's loading settings from elsewhere. So the question is, there has to be an easier way to do this. It's doing the same thing. Are you even going to try? It's all warnings, all warnings. Oh, but it appears to be continuing. Guess we're getting somewhere. Does this make me a more hardcore programmer if I could do this stuff? This doesn't feel like, this is like a total departure from doing microcontrollers. It's a different method of doing microcontrollers where you're a little less specialized to one processor. I prefer to be specialized to one processor. But alas, if you have many programmers working on projects, you do stuff like this. Make a new Amiga keyboard, yeah, right? I have an IBM Model M that I could QMK. That'd be kind of cool. I don't want to become a keyboard building channel. I can't stand people who build keyboards. They're awful, subhuman, just waste. I'm just kidding. I don't mind you guys at all. Keyboard's a wonderful project to do. Just mechanical keyboard people can be crazy. Get a cheap mechanical keyboard, $500. The 5950X would compile faster. It has one job to draw from. One singular job. It is going pretty slow, isn't it? Man, the new 7000 series is going to be pretty rough. I can't believe they're more efficient. After I bought all that computer hardware, AMD is like, by the way, here's a cheaper and more efficient alternative that works better. Really? Oh no, I lost a viewer. They were probably a mechanical keyboard specialist. No, we lost one. Oh. How could this be? By the way, I'm not going to be doing a Saturday stream this week. I can't do one. I got to do stuff. Yeah, it's true. It's true. The second you get a new CPU, the old one is... Well, that happened with the graphics card, too, because I guess the only reason the 6900s were suddenly available was because the 6950 was coming out less than a week later. I bought it and I received it, and then like 4 days later, the 5950 came out. 6950 came out. Not that I need the 6950. Bootloader not found. Okay, hold on. It timed out. Give me 1 sec. Yeah. Okay, so if we go here, then the screen works. The screen work. Okay, the screen doesn't work at all. Why have you forsaken me? And remember, we got the other OLED, the one button test to work just fine. We have a plan. That's all we have right now, Hellgreen. I gotta learn how to do all this keyboard crap and get the software to go onto the MCU so that we know that part of it works. Once I get, because right now we're building up the skeleton. It's actually, this is a really good time. You've come in at just the right time. Instead of yelling at you for being dumb, this is a good opportunity for me to actually explain everything from the start, just because we have a bit of a revolving door of people coming in and out of the stream, and I need a quick break, so it actually works for me to explain everything. So here's the deal. The other day, I was happily computing along at my desk, doing the keyboard cat thing, you know. Look at me, yeah. I'm talking to friends on the internet. I'm doing stuff. I'm a programming expert. Look at me go. Here I go. And then suddenly, I spilled a bunch of bullshit onto the keyboard. It was iced tea. And this is like the middle of the night. And I said, fuck this. I am not dealing with this right now. I'm not firing up the air compressor. I went like this, shook it, and then dropped it on top of some stuff. Went to bed. Came back. Apparently I spilled a lot more than I thought I did. I thought I just got a little splash on it, but it was pretty much just like the fronts of all the keycaps were soaked. So I did a little bit more shaking it out, put it in front of a fan, tried it. Didn't work. Opened it up, dried it off, cleaned off the circuit board, did multiple alcohol washes to the circuit board and everything. It was unplugged, by the way. No, there was no vodka in it. It was just powdered iced tea mix, and it was very late at night. It was 100%, I was sober, but I was also very tired. So, diet iced tea, no sugar. I don't do sugar drinks. So anyway, I did all that, and I did the alcohol wash on the board a couple times, made sure that everything was super duper dry, plugged it all back in, didn't work. Did more alcohol washes, plugged it back in, worked perfectly, put the front bezel on it, stopped working. What the hell? Took it apart. There was a dodgy power connection for the main USB inputs. So I found the only crimps that would fit that size of socket that I had, and I sacrificed them, and I made this into, you know, a slightly longer wire that plugs into the back of the keyboard. Plug it all in. Doesn't work. That's a problem, because everything is super clean. Everything is super duper clean on this keyboard. The only weird parts are where the silk screen has come up a little bit. So on investigating it further, it seems like the controller is dead. Just completely dead. So the question is, well, first of all, I immediately bought a replacement keyboard, which was very expensive. This is not an inexpensive mechanical keyboard. It is fairly simple for what it is, and I'm a little bit disappointed that this fucking processor is so ready to just bite the dust. So I got into the world of, and I figured it was about time, got into the world of custom building mechanical keyboards. You see, typically with QMK, that set of QMK is one method by which to put an operating system into your keyboard. Now, this all exists on a microcontroller. The Sonics microcontroller used in the Code 10 keyless keyboard, absolutely not compatible with QMK. It's like an 8-bit microcontroller. You need like a kind of a powerful microcontroller to use QMK in the first place, and it opens up a bunch of features that you could use. So looking into QMK, I mean, my MCU is dead. I've got a replacement keyboard to use as a backup coming in the mail for way too much money. I want to remove all of the stuff on this keyboard and take it over. And so the method to do that, the method to do that is to find a processor that's compatible with QMK and just bootstrap it onto the back of the device. Well, a little bit of problem. What processors do I have? Well, I've got a lot of different ones. There are various different price tags associated with them. I've decided to go with the Raspberry Pi Pico. Raspberry Pi Pico, I got conned into buying a bunch of these a little while ago, and they are $4 a piece. $4, 4 of them. Only $4. So at only $4, it's a no-brainer. Why don't I just go with that thing? Well, the problem is I've never used QMK before. I don't know how this shit works. Turns out with the Raspberry Pi Pico, it's very easy to just kind of toss firmware into your microcontroller and have it work. x86, man, I got no idea. You'd have to Google that because I don't know what you're talking about. The Raspberry Pi Pico is an RP2040, whatever that means. Yeah, it's a microcontroller. Yeah. Okay, so x86 would be like a computer processor, right? This is like, this thing runs code on itself, and it scans through code and runs it one line at a time, and then it executes the commands that you give it with varying degrees of complexity to that, depending on how you want to program it. But anyway, so we're trying to get the skeleton of the new brain. The brain is a skeleton? What the fuck is Obama talking about? Anyway, we want to get the skeleton of our new schema figured out. I've done the reverse engineering of this board, so I know where the rows and the columns are. I know how the diodes are oriented in order to implement them, and I know what button corresponds to what microcontroller pin. It is a very weird layout. It is a very weird layout, right? There's a Discord I frequent dedicated to hacking QMA code into different keyboards running the Sonics Micro. Really? Oh, well, this one I think is an 8-bit Sonic, so they'd probably have a little trouble with that. I'm not going to do that, though, because this microcontroller is dead. There's no point. Maybe reflashing it would be okay, but there's also a secondary microcontroller just for running the RGB LEDs. This thing will do everything on the keyboard, but the 2 RGB LEDs right here. So I think part of this extra processor, I think what this does is it can flash this microcontroller to run defaults. I think it reflashes the entire micro to run defaults. Now we got that working with this keyboard. We set the jumpers properly, and we saw the LEDs say, yeah, I'm flashing the microcontroller and everything's good now. And then I plug this into the computer and nothing happens. I don't know what's up with that. So anyway, something's broken in the micro, and I don't know what. It doesn't matter. It's going away, and it's getting replaced with our own thing. So I'll have the backup keyboard, but I'll also have, you know, something I can really play with if I feel like putting weird stuff onto it. So what we've done just now is we've successfully gotten to the point, well, I guess I can't say successfully because nothing's lit up yet. We got to the point where, yeah, see, that's not working. Something's wrong. I installed QMK and their little flashing utility. I've got all that stuff working. I've got all the code on the computer so that we could run the Hello World program on this thing. And we were able to get a button press to hit the letter A, which is important. But now, nothing is doing with the OLED screen. I need to determine whether or not I've wired it wrong. Ground, VCC, clock, and then data. Clock goes to the inner pin. And then, where's my thing? Hold on. Where's my thingy wingy, chat? Oh my God, we got so many tabs open. Clock is running to the inner one. So my pinout is correct. My pull-up resistors are possibly a little bit weak, but I think something else is up. I don't know what reaction you want me to say to that. You should go outside. All right, stream's over. There goes my primary income. Like, you got me. You finally got me, chat. I should go outside instead of making money off of the internet. And I should do, like, die of diabetes or something. I don't know. Anyway, we're trying to get this LCD to work. So what we need to do is we need to get the LCD to work with the one-key keyboard. And then we can worry about how to run multiplexing. Because according to my reverse engineering and the parts that I have on hand, the way that we're going to get away with having such a weird matrix on this keyboard. This keyboard's a little weird. Here's how the rows and the columns are sort of laid out. This is by microcontroller pin. I just kind of kept microcontroller pin in there. But the keys in the rows and columns, they're not very organized. Now, there are 18 columns, which is a little weird. 18 columns, and then instead of just having all of these as a row, the rows are kind of split. So for instance, pin 34 goes to these, and then I think there's a couple others just like in weird places. Looking for 34s. Those, oh wait, yeah, and then these two. So like that's one row. Very strange. Hard to map out, and we're going to have to map all that out, but we're also going to have to map all that out in relation to muxes. Yeah, I think their justification for having that split, the reason that they're split up like that, is so that your home row and your you know, the fingers that do all the work, or that do a primary amount of work when you're typing, get more scans. It's so that it's not scanning across this entire row all at once. So it scans here, then it scans here, then it scans here, then it scans here, then here, then here. I think that's the scheme behind it. Try the I2C pins at the bottom right side of the Pico, pin 22 and 21. I had an issue with 1 and 2. Yeah, I think that's what we're going to do now. Yeah, when I use the USB port. That is exactly what I was thinking, Celia, and you're correct. Hold on, I'm gonna cough 1 sec. All right, so yeah, pins 0 and 1 might have some trouble when you're using USB at the same time. Now, in order to alleviate the fact that we've got 18 rows and 12 columns, or sorry, 8 columns and 18 rows, I am gonna take these three buttons, these 3 columns, and I'm going to roll them into adjacent rows. So we'll just make, sorry, adjacent columns. So we'll make column 15 also be column 18, and there's no conflictions there. So that'll reduce us to 15 columns and 8 rows. And the 8 rows just need power on them. So what we'll be able to do is run binary out of the system in order to put voltage on those rows, and then once the row is active, we need to very quickly scan through the column pin by pin in order to determine what levels are high and low. So if it's slow, we can double the speed by putting that to 2 pins on the microcontroller. We can read 2 at once, possibly. Getting this to work in QMK is going to be a beast, but it can be done. I've seen code. I've seen it. I've seen it with my own very eyes. With these 2 eyes, that one fateful night, I was the observer of the witness to unholy happenstance. Anyway, yeah, too much work for it's a $200 keyboard. I'm gonna make it work. It's the thing about, also, hello, cousin. That's the thing about having expensive things, is I am not gonna let it break. Fuck, man, I'm not gonna fucking fuck. Ugh. This has been a lot of work reverse engineering. This is supposed to be a quick project. There are never quick projects around here. We were supposed to be working on Burn the Subs. As soon as my keyboard is back up and running and functional, we are ostensibly under the gun to work on Burn the Subs. Still rolling with a Model M. I've got one up on the wall. I would love to QMK that thing. It'd be a little blasphemous, though. But who has a PS2 port anymore? So yeah, this has been a lot of work, but I've wanted to work with a Pico Pi, this microcontroller, and I've wanted to do something with keyboards because, I mean, you guys can see plainly that there's like 15 more people watching me because I've got keyboards in the title. Like, I'm out here to get views. All right, so I2C isn't working. Let's roll it into a different port. IBM ThinkPad is PS2. How old is that? Jeez. We want to use different pins. So in order to use different pins, we got to go to config.h, and we got to change it from GP0 and GP1. So we got to look at our pin out. And Silly was saying the lower right hand. So 16 and 17, they're still on the same bank. So I2C 0. So GP17 is clock. So pin 2 becomes 17. And 17, 16. So I just need to put a 7 there. And then this one's 16. And then we save that file. And then I change the wires so that the clock, I can use much smaller jumpers. Much smaller jumpers. Sorry, yumpers. Honestly, this is the stuff I hope to see here. See, that's one thing that I need to be doing is I need to follow trends a little bit more, because I get kind of wrapped up in my own projects, and my own projects are weird and eclectic. Burn the Subs is one of those universal projects that brings other people in, mostly because I am conning all the K-pop people into watching a streamer with a title that sounds like a K-pop thing. But other than that, aside from conning people into watching, which one was clock again? Hold on. Clock is the inside one. Okay. Aside from conning people into watching, having projects that have the mass appeal is something that I need to do. So working on projects like this, you know, people tend to want to see that kind of stuff from their hardware streamers. So yeah, it's the part of the thing is I don't just, I mean, I could wire up all these buttons and ow, sharp. All these buttons and switches I could wire up to the GPIO on this thing, but then I wouldn't have any LEDs, I wouldn't have backlighting, and I couldn't have a screen. I would like to add a screen for fun. So the masses love that shit. I would love to find an orange OLED screen. That would be nice. One of these little... It has to be this size, though, because it needs to fit above the arrow keys. I've got space for it right here. So what we're going to do, hardware-wise, if we need to build a board that's going to let us test the muxes and the demuxes, right? And that board we can put on this just right from the get-go. We need to build a board that's going to do the muxing and the demuxing. We need to test the speed of that. It was like 1 or 2 keys, right? We can build the board maybe over here, and I can wire it up to the perf board, and we can hook the 2 buttons up to it and see what it feels like. If I can twiddle the buttons and get good response from it. Then what it's going to look like is that board will just get double-sided taped to this, the foam tape, to this board, as well as the Pico. Pico's going to use these USB inputs, and then I'm going to be soldering wires to basically all over the board in order to take over the systems once we desolder all the stuff that's already there. I know building a keyboard is fucking complicated. You have keyboards for like a billion years. Why are they so goddamn complex? It's fucking ridiculous. All right, so let's compile this software and get it uploaded. That's not. There's nothing there. There's nothing. There's not. It's not. Where did my desktop go? Why is this here? What the hell did you do to this keyboard? I was drinking iced tea late at night. Powdered iced tea in tap water. You can always tell when it's tap water. And I spilled a little bit of iced tea on the top of the keyboard. So I immediately flipped it over and went to bed. Because that's what you should do. I didn't feel like firing up the air compressor. So as such, when I came back down to it the next day, it was sitting in a puddle of iced tea. It was a larger spill than I had anticipated. So I cleaned and cleaned and cleaned, and nothing was fixing it. For a little bit, it was working. And then I put the front bevel on it, and it just decided to break again. I did like alcohol washes and everything on it. This is like a $200 keyboard though, so I'm not letting it die. The MCU, the actual controller for this thing, is just dead. It's just dead. So instead of like resurrecting the microcontroller or trying to work within the system at all, apparently there are people who try to get QMK, which is the quick mechanical keyboard stuff, try to get it working on this specific type of microcontroller, which is like I think it's Chinese microcontroller. It's fairly limited. Instead, I would like to use more universal open source things. So I'm going to put QMK on a Pi Pico, which is a $4 microcontroller board that's very capable. I'm going to run an OLED screen and all that other stuff. We're just doing cool feature times 3 and then possible upgrades. So what I'm doing is I'm making a mutant out of this thing. We're using QMK to make the Pi Pico into a keyboard and then have it take over the job of the old Sonix microcontroller. But we're having a pinout issue. I don't have enough pins, so I'm going to use muxes, which will make things a little bit weirder and make my code a little bit weirder. But I think it should be good. I am a man of many keyboards. You actually still have my keyboard, FK Productions. I think it ended up on a milling machine. That was like a cherry red keyboard that I used to have. I got like I actually have a bunch of keyboards sitting around. The problem is the replacement keyboard that I had for this one is a Razer keyboard, and for some reason, the Razer keyboard, it registers a button press at the very top of the button press. So it's just completely and utterly gobbledygook coming out of me from that, because I'm not used to it. I typo everything. Windows on-screen keyboard and a mouse. I have been there. I have been there. The best part about Windows on-screen keyboard is the predictive stuff that it does. It does predictive text, so you don't have to type the whole thing. The power of sparks. Yes. Glitter. What's your power again? I just do glitter, and I look like really 80s. I dress really 80s, and I have like glitter comes out of my hands. It's what I do. Nobody wanted to be Jubilee. Come on. X-Men Arcade. I'm going to be Jubilee. I got sparks. Oh no, I am dazzled. Eh. That's Dazzler? No, that's a little different. Mesmer, which was the origin of the term mesmerize. Oh my god. This thing takes forever to compile. There's a lot of stuff in here. I mean, I guess QMK set out to be like the mechanical keyboard program, and so it has to be universal, and so you get all this bloat. Oh, why are you in Phoenix? Oh my god. 125 degrees Fahrenheit. I don't know if you saw FK, but I got a new puppy. I got a puppy. I've been sharing a lot of puppy pictures on the Discord, but I can show a couple here. She's too young to be down in the shop yet. I got a puppy. She had friends over today. She got to see this dog is gonna look a lot like, this dog is Willow. This dog is Willow. Hold on, I gotta do. I don't think there are too many doxing things here, but this is Willow. She's a fluffy corgi puppy. She is 11 weeks old. She was born in a heat wave. Future junior engineer, wide blanket Pipa. Oh my god. Yeah, and this is Quillen. This is our neighbor. You can see how his hair is a lot longer in some places. So he's a fluffy corgi. He's very long, like his mother. She has the same mother. She's gonna be super cute. Hold on, let me see. What picture do I have next? Oh, this has been her latest. This is the latest meta, by the way. This is how she plays with me. My socks are awesome, and you guys can all get fucked. She comes over with a toy, and she plays with the toy, and sort of cuddles up against you, right? And this is sort of her. This is a feint. This is, oh, I'm so cute and cuddly, and I'm just playing with a toy right next to you. And then she bites you. She just starts gnawing on my pants. That's what she does. She just starts gnawing. This looks like she's like nuzzled against me. No, don't be fooled. That bottom jaw is under my leg doing this. God. So she's getting a little mouthy. I tried to take a good picture, but she started biting. Oh, let's see. She smelled that I had treats in my pocket at one point, and so she started biting. She's very bitey right now, but she's very, very cute. You might not be able to see her in this photo. She's right there. So yeah, this is Willow. She's got, yeah, hey, you got games on your phone? She's got droopy ears right now. They're probably going to perk up when she gets a little older. The fur's wild, her head looks like a Papillon or a Jack Russell. I said she looks a little beagle, but the game that she loves right now is that little duck that she got from the vet is the only squeaky toy we have that she can squeak. The back half looks like corgi. Yeah, so the tail is not cropped. She has a little bit of a nub, and that's natural. But she's a fluffy, so her hair is going to grow out. Her coloring will probably change a little bit from the puppy. But I mean, this is her thinking about biting me right now. That's what's going on there. You can see that the little gears are turning, and she wants to bite me. She's very funny when she tries to get away with stuff, because, you know, you're smarter than her, but she's clever for a dog. So that's where that whole feint comes from you know, getting close to you and acting like she's doing something else. And then you see the gears turning, and then she just goes and bites. She likes that bed. You're going to want a robot vacuum? Yeah, I don't know how much she's not shedding a lot now, even though it is summer. She really likes cold because she was born in a heat wave. So she'll go to like any stone slab and just sleep there. We don't have any robot vacuums. I don't trust robots. But yeah, that's Willow. She liked to bite. She bites. So that's why I've been super distracted from stream and the stream projects. I've managed to do quite a bit with this thing, but oh, bootloader. I managed to do quite a bit with this thing, but it's been kind of excruciating because I need to go tire out the puppy before, you know, before I work on my own stuff. Oh, whoops, I gotta hold down the button. Program waits a while for me to get it all set. There we go. Flashed. Still nothing from the OLED, huh? Did I reverse power it? Did I get ground and get VCC wrong? Nope. VCC and ground are correct. And that should be VCC and ground. My question is whether or not I need to do VCC enable. Let's take a look at it. Let's look it up. So this would be... Wrong one. We need to go to the other one. There. RPi Pico... Where are we? I got so many browser windows open. Today's been a big tutorial day. RPi Pico 3v3 enable. Is it defaulted to on? Celia would know this, but it's probably too late for her. She's gone. Robots will take over the world. They're still too dumb. If some guy in Boston can hit it with a hockey stick and it falls over... I mean, like, lately we've seen this copy of the... It's default on. Okay, so that should have 3v3 on there. Let's test it to make sure. Where'd my multimeter go? Oh, it's literally right in front of my eyes. Terp. DC volts. I've been watching D&D, and somebody says automaton in a very weird way. They say automaton. And it's like, it reminds me of when I say multimeter. Wow, that is a dirty voltage jumping all over the place. Automaton. Automaton. Oh. People need to read books. Read books and Google words. I don't know why this LCD isn't working, because we've got... Well, okay, so push down on the pins, and then unplug them and reverse them. Backflip it and reverse it. Let me work it. Nothing. I don't even know if this thing works at all, or if we gave it bad code, or what. Let me put it back to the way it was. That there, this here. And then hit the button. Nothing. Let's reset the microcontroller. We got to go through all the individual steps. I know the button works because we loaded up the one button thing and it was fine. Of course, we've messed up all those files, so... Breadboard not responding, yeah. Son of a bitch. I need to set up a status light. Usually I do a status light on these things. So SDA and SDA is all the way up top. Oh, and clock is on the inner one. So this is actually backwards right now. So SDA and SCL I need to reverse. Hold on. Reverse the pins. This one goes here. And this one goes here. Probably be better if my I2C was on the other side of the board, and then I could have these come in from over here. Or I could have done the resistors going down like that. Oh well. Would have been cleaner. Woulda, coulda, shoulda. Please? Please do thing. Show stuff. Please? Please. Ah, man. Okay. No, we changed them over. We already did that. Jeez. We already did that. Celia suggested that she had trouble with pins 0 and 1, which is what I was using before. We've gone to these over here, which are not used by USB. And actually, none of the pins that are used by USB go directly to the microcontroller. They go directly. No, we've got like just like an issue, just like a configure. Oh, wait a minute! Dun dun dun! Okay. All right. That's a little glitchy. Oh no, it's glitchy on camera. It looks actually totally cool. Man, that's cool looking. Yeah, it's way less glitchy on camera. That's a smart looking display right there. That's what that is. I think what I can do is, because it's a white LED, I have ways of making it match the color of the rest of my build. I could put orange tape over it and make it look orange. That is a smart looking display. What does the tap do? Beep. Oh my God. Look at all those. Oh my God. This is why we put all of that code in there. Yeah, load bongo cat. I know people, it looks like you can get away with some pretty complicated stuff. Oh my God. It's smarter than I am. What am I gonna do? This is gonna take over the world. I must destroy it. It's my only hope. I'm a Hollywood writer. And I don't trust technology for some reason. That's the only thing I think, not the only thing, that's one of the best things that Roddenberry did was in the series Bible for Star Trek. There's always a statement that says technology is not the enemy. It is the solution to the problem. See, that's actually lit solid, but because of the rolling frame rate of the camera, you guys see weird stuff. It's just tough when every single fucking show that ever does sci-fi, because that's the nature of sci-fi, right? Every show that does sci-fi does, and then it went wrong. It's like, stop doing that. That's every other row. It's every other row. Vertical bars. How many programs are in this thing? Ah, crosshatch. That is some resolution, actually. This thing, you could display some, you could play Shadowgate on this. Ugh. How about a nice game of checkers? If I hold it down, it changes its orientation. It's a smart little display. You could make an interrogator for your Dragon Ball Z cosplay. No. It's all the same stuff. It's just if I hold it down again, it'll flip again, and this time it'll be this way. And get back to the original program. So the question is, should I go back to pins 1 and 2? I guess I don't need to. I can keep it on those pins. I can keep it on those pins just fine. The next step in this whole thing is going to be building up the muxes. And the title is almost entirely concerned with those muxes. We need to make it scan an entire keyboard via mux. That's going to be a trip. This will be the original orientation. So the question is, can I have it read all of the columns from one pin? I mean, this is a powerful enough system that I think I can have it read stuff properly. Now, I'm going to have to learn a little bit more about how this stuff works before we get there. We've got all of the, basically have all the base stuff. Yeah, this is, I believe this screen is the one that they used on like the pregnancy test and stuff. Once you get into this screen, you could use like a processing program to make a like screen to I2C. You do like a pixel scan on a display window, and then you translate that into 2-bit, or you do that initially, you get like a 2-bit, you lower it down to that. You put that into I2C, and then you put it directly to the screen, and then you put this little tiny screen on whatever item previously had one. So if I really wanted to, I could also I could get to the top of Reddit. I could be super popular if I wanted to by taking something like this thing that I found the other day. This is the one drop glucose monitor. It actually has a tiny little VFD display inside of it. What I could do is just fucking core out the inside, and I could put this display right behind there, and then I could run HDMI into it, or whatever's on the screen. I could play Doom in a little window with a processing program, and then it would look like I got Doom to run on a blood glucose monitoring device. The problem is this isn't very recognizable. This is not very recognizable. You need something that everybody has seen before, right? Yeah, VFDs are awesome. This thing has a little VFD display in it. It's the one drop. It was like a brief little stint in making a glucose monitor that doesn't look like something stupid. Although this does look kind of... I always hated the chrome. I always hated the chrome. Oh, is there a direct one? Carmack would be thrilled. It's not really computer science, though. It's not really computer science when you're just putting a display behind where a display goes and it already displays what you want it to display, right? That doesn't really make much sense. But it fools the internet and people go bonkers over it. I mean, you see it at the top of Reddit all the time, and you have to be the one looking at that like, oh man, now I'm really cynical. HDMI has I2C display functions on it. Ah, I do remember there being I2C. I know that project that we were going to do for Octoj, one of my moderators, was to make something that we could plug into his monitor that would keep it from glitching out when it got partially, like, if he turns off the monitor, it won't glitch out all of his screens. No, not... okay, so the display in here is a VFD. It's a miniature VFD. I don't know what... maybe it's an LED display. I think it's a VFD, though. Let's find out. I might as well just answer that question right now. I'm not even using this thing, so... Hold on, I'm getting... Ugh! Jesus. Because, yeah, you do have to... In order to get vacuum fluorescence, you have to do vacuum tube stuff, which includes heaters. So maybe it isn't. Maybe it's just a little... maybe it's like an early OLED. How do I take this thing apart again? This little flying saucer mofo. I'm not going to be using it in this thing. Yeah, I bought this one drop thing, and I thought it would be a cool way to have something that didn't look like a blood glucose tester. I don't even do that anymore because the way the constant glucose monitor works that I have, you don't need to do finger sticks at all. I'm forcing the issue and just literally prying this thing into shreds. You are no longer to hold together. That is my command. I have spoken. There's a giant QR code on this thing. It's an interesting design. I just wish it wasn't chrome. Bluetooth. Yeah, old Bluetooth, Jiminy John. Here. Take a closer look. Let's do a multi-micro. There we go. Where's my thermals? Did they stop? Okay, hold on. Let's get the thermals up again. Thermal cam. Deactivate. Activate. What? What's going on here? Don't tell me these things are finally broken. Deactivate. Activate. I hear it. I don't see it. There they are. They're still a little cranky. Frame rate's okay. They're just a little dirty on the stuff going on. All right. Let's see here. So, this is the one drop glucose monitor or BG tester, whatever. So it has two CR2032 batteries that connect to it. So I'll connect the batteries in just a sec. We'll take a look at the display. It's all test points underneath it, probably because this drops into a test rig before it leaves the factory. This thing I bought a long time ago because it looked like a cool, different glucose tester, blood glucose tester. Do we have a year code on this? I don't think it was 2011. 94V0 is describing the fire properties of it. 411001. It was 1941 when I bought this thing. No. We got a little Bluetooth module on it, too. I think the hope was that this thing would talk to what I needed to update the glucose levels in and help me keep records. But we have a coil, a big coil, probably for creating the high voltage for whatever the display is. What the manual, what each test module does. Oh, did you see a 2016 on it? Did I get this in 2016? This is for reading the strip. Yeah, they had their own kind of like strips. Yeah, March 2016, huh? Got a button over here too to do functions. So let's see what we can get to light up on this thing. So it's CR2032s, but they're in parallel. So we're basically just giving it 3 volts. So I'm just going to bend this up. Yeah, it could be. Bend that up, and then we'll get leads on it. So I'm going to turn on my power supply all the way over here. I really liked the display on this thing. It was very weird. Negative on the 2032s is this one, I believe. And then positive is the outer shell. Just got to make sure I don't hit a test point and kill it. And then we are set for 10 volts. Okay, before... No, sorry, 3 volts, 10 amps. Okay, so that'll... CR2032 is... Yeah, that's 3 volts. So, power on? It's drawing current. Button. Look at that thing. Oh God, my last level was embarrassing. Oh God. My glucose levels are embarrassing. Look at this display though. How cool is that? I think it's an individual LED kind of deal. I don't think it's plasma. Yeah, it's really nice, right? I don't think I could ever use this in anything. I don't know how I would even approach this. Really cool display. Cool to get this working on the keyboard. Well, who said anything about high voltage? I mean, we just have a big coil. But yeah, maybe it is plasma. I think a Pico will have enough pins to run it. I don't even know how it's hooked up. We've got a flat cable that goes down to the bottom there. Now the rest of it is on standoffs. Obviously no backlight. Yeah, it just kind of like fits into there. And then it's got the flat cable going to it. I don't know who or what or when, where, why. All right, I power disconnected or turned off. Can I? Oh, I can peel it up. Hold on. I don't want to break it. I don't want to break it, but I might. I might accidentally break it. There's some adhesive down here. Oh, no, it's this right here. Popped out. There we go. See the little adhesive and a little flat cable connector. M430F5419A Texas Ints. Man, industry is so weird. They use such weird microcontrollers for everything. Like who's going out of their way to use a TI micro? It's weird. It's just weird. So we have a huge coil. Yeah, it might be 2016 OLED technology. Because, yeah, there's nothing on the other side. We just have one big coil. One big coil and a big cap on it. And then the TI thing seems to be... I mean, there's a couple, like... That's probably more to do with, well... There's a lot of stuff up here with like analog devices, and what these glucose monitors do is they kind of have a fixed voltage level that they reference, and then they read off of the chemistry of the strip when you apply blood to it. It takes 5 seconds for it to kind of percolate and then start giving levels back. So there's a lot of analog electronics in this section, you know, for digitally reading the capacitance, I believe, of the strip. I think capacitance. I'm probably wrong about that. But then back here is all the stuff running the rest of the chip. And we got this massive, coil. I don't know what the massive coil could possibly be doing. Well, might have, no. This is a Bluetooth module. All this stuff should be just normal old voltages. I don't know why you would have a giant coil on it, unless that's some kind of a bastardization of an antenna. PZ, Yeah, I guess these are coils. What, is that an MSP 430? What is that? I don't know what's special about it. I've heard the name before. Yeah, this is from a company called One Drop. Very weird. But like, what is this display that I'm going to scratch the display? MF1-A, pins 1 through 15, and then 01320. Oh, there's the part number. Hold on. Oh, of course, I flipped it and it's upside down now. Oh, God. V16B, WV16A7. This is a big part number. Probably has the resolution in there and everything. I don't know if we'll be able to find it. I mean, I could get the numbers out of that, but displays are so tough to find. V16B4 2B something something. Hold on. Where are we? I'm in the wrong window. Yeah, early OLED seems like the best bet because there would be other high voltage stuff around it. Nope. Yeah, these things you can buy everywhere. These little OLED displays, they're neat. They're pretty neat. I don't know if I'm going to be able to find anything about it. It's 15 pin. No, close. Actually, I think we might have a winner. I think that might be it. I mean, remember, these one-drop people had the same resources pretty much that we have. So looking at the shape of that, how it kind of like drops down like that, that might be it. The upper left-hand corner. Or possibly, yeah, these. Like that one right there. How you would go about using them is beyond my recognition. I would not be able to figure that out. But that pretty much looks like it. And if it matches 15 pins... Oh, look at their little... That's cute. Oh, look! It's some kind of a health monitoring device. In color. 128 by 32. SSD 1306. I2C, 14 pins. This one's 15. SSD 1306. Wait a minute. Wait just one freaking minute here. That's not the same display as what I have. That's what I have in the keyboard. If this thing was 1306 powered, that would be hilarious. I'd have another screen that I could use. We can even wire this up right now if I can solder small enough. If I could solder it small enough, that's the only problem. Yeah, that wasn't a data sheet, was it? Ah. Where do you get the pinouts for things like this? 4-wire SPI is what I would assume we have. This one has 15 pins. And then the screen that's actually on this is a little larger than the one that we just got out of the blood glucose monitor. I say monitor, it's a tester. Yeah, the one on the Pico, I mean, there's 4 pins there, but the wire is bent under much in the same as all these other ones are. It's just the display is a little bit different. This one has like a screen over it, and it's less reflective and it's smaller, which is interesting. This is much smaller. So this is like probably an early edition of those OLED screens. That's kind of cool. We randomly just found another OLED screen that was very similar to what we had in the keyboard. if you needed to run something in a slightly smaller screen on I2C, maybe we could get Doom to look like it's running off of this thing and put it in God knows where. we could put it on anything. What are pinout? They don't tell you. They don't tell you. You need to get pretty deep into the weeds in order to figure it out. White, red, blue, yellow, green. Yeah, I don't know. I mean, I guess if we were really adamant about it, we could probably figure out exactly what all the pins are, but yeah, and get it to run. Well, it's the same IC, but there's SPI and there's I2C. If we got I2C, it would be kind of funny if I got my keyboard display to run with an old blood glucose tester screen. I'll put this screen aside. I'm not gonna get this thing running in the thing, but I will put it aside because that's kind of funny that it is in fact OLED and it's a pretty nice little thing. I'm glad we had the knowledge to get to the bottom of that, because that glucose tester I thought was really cool because of the screen. If you actually said something about a blood sacrifice being required, that is hilarious. That's funny though. I can't believe we found an OLED that runs off of the same style driver as the rest of the keyboard on the day that we're working on the keyboard. I've been cleaning stuff out around here in order to organize my life just a little bit more. Right. Dr. Plugger, hey, thank you for the Prime for 35 months. 35 months of Dr. Plugger. That sounds awful. Well, thank you. I appreciate that. It actually looks a lot more like this one, doesn't it? With the, yeah, this looks, wait a minute. This looks extremely similar. It's $1.50. Are you kidding me? Are you kidding me? And it is that chip. 128 by 32 blue 15 pin. Oh my God, I think this is it. It's just that the interface on the cable over here is a little bit different, but I think this is the display. I know, we're gonna make it big with this. If I could just get it to the right, if we could fence it. 4-wire SPI, I2C, OLED, 0.91 inch. This is ridiculous. I've never before... Okay. This smug Alibaba face. Oh, there it is. 2P, 2N, 1P, 1N. Battery, VSS, VDD, CS, res. We just want S clock and SD in. Serial clock and serial data. And then there's another VCC. VDD and VCC, serial clock, serial data. And it's possible that I could get the stuff that we just saw on that little display that I have running on this thing. That's kind of cool. I've never before had that happen. I guess these OLED displays at least decided to standardize early on. Because like when you take like an LCD out of something, there's just nothing. There's no information at all about it. In some cases, for instance, if you had a laptop that had a really nice display in it, and I've done this before, if you had a laptop that had a common really nice display in it, you can Google that panel and you will find an adapter for that panel that'll turn it into a monitor. So you can have an HDMI input. I mean, it's a great way to build like a portable console because you could just monitorify your otherwise dead hardware, right? So you can do that. Typically that works. But when you get into devices, when you get into things like old phones or old like handheld game third-party weird stuff, and you start looking up those displays, you're not going to find much information because the technology moves so quickly that they just abandon old stuff. And so those, like the data sheets on exactly what the ins and the outs are on those screens are rather proprietary. You need to actually contact them, talk about working samples and engineering samples and get their data sheet because they're not listing it publicly, which is unfortunate. Electronics thrive off of the universality of the data sheet. The data sheet is a wonderful, semi-standard way to tell every single engineer in the world at a glance what your stuff does and how it functions and how to break it. That works very well for us because when we reverse engineer stuff, we look up chips and we look at, and then we burp really, really loudly. Sorry. My stomach is mostly empty except for carbonated soda. That's great. We look up all the chips and we figure out the interactivity between the chips, and then the sample circuits on the chips generally tell us what everything else is doing in that circuit. And then we can see what kind of little weird stuff that people who design hardware do and learn from it. We do that a lot here. I try to do that a lot here. Kind of run out of stuff to take apart. But we do try to do Fridays where I take stuff apart and we kind of learn the lessons from the thing that I'm taking apart. With screens, all bets are off. It's a madhouse. If you have like a little color screen on the thing, you're like, oh, cool, little color screen. I'm going to use that on something that no, you can't. It's like fucking ridiculous. It's so bad. Because you look it up and it's like you get all these eclectic pinouts, or you get some weird ass, you know, this one's LM1, LM4, LM85. What does it mean? I don't know. Nobody's telling anything about it. What's his name? One of those electronic-y, kind of better than me people who do YouTube. Ben Heck. Ben Heck did a whole thing where he shows exactly how he's trying to figure out all of the pinouts from an LCD, and he somehow figures it all out. Good God, how do you even get to that point? It's so much work, but he was able to do it. You could just go on eBay, look up the part number of the screen, find something that turns it into a monitor, and it's so much easier. That's why this is shocking, because this little LCD screen, you would think it's so application specific that the pinout's just going to be something weird, right? And even if it did have a common pinout, you'd never be able to find a listing of that pinout. But here we are. So I think in part it's because the one-drop people were trying, you know, they're not a big company making a screen for a test device, so they're not going to order 10,000 different screens and figure out which one exactly it and work directly with the manufacturer. They're just going to buy something, you know, COTS, commercial off the shelf, that's going to have a defined pinout and advertise to them. So that's what I like to see. It's cool that we were able to see that. Now, I could try to get it functioning with the keyboard display now that we have a pinout. What do you guys say? You want to try that? I want to try that. I'm going to do this for me. I'm doing this for me. We're going to get fixing screens. Usually, you know, if you can find a replacement screen, that helps, but sometimes you just can't. All right, so we want to get 4 pins out of this thing. Problem is these pins are absolutely microscopic. So, and I don't have any breakouts specifically for this kind of thing. Whoops, daisy. I'm gonna end up scratching this thing before the day is done. All right, so this little guy right here, supposedly we got a pin out for it, and these absolutely microscopic wires. Now we're gonna solder wire wrap wires to this. So the first step is to establish our environment, show dominance over the circuit itself. So what I'm gonna do, big old chunk of Captain tape, which doesn't leave a residue. That's why we use it. It's high temperature, it survives soldering. It holds stuff marginally well, but most of all, it doesn't leave a residue behind. It's nice and clean. So we get nice and clean, big piece of Captain tape. Let me close the vise. The vise is just here as a backdrop. It's just something that'll add a little bit of weight to what I'm working on and allow me to move the iron in and out of it easily. Big old piece of Captain tape. Yeah, we're gonna get into muxes, I guess, next time, because this'll take us a couple minutes of getting distracted. So I got our pin 1 and our pin 15. So according to our pinout, where's my pinout? Pull that up to the top. VCC, VDD, plus and minus. Now, how big is the wire wrap wire in relation to these pins? Might be doable, might be solderable, might not be. We'll see. What's up, Udenjaeger? Have I seen you somewhere before? I feel like I've seen the name before. Or is that a Titans reference? Okay, so let's see if we can get 4 wires on this thing, and we can put those to a header. me get the power wires out of here. And we can see if the Pico Pi can run this screen. And then someday I'll have to figure out, how we can, I just heard a weird noise. It sounds like somebody went, ooh. Someday we'll figure out a project for this thing. It might have just been like a squeak noise from me moving the stool around. It's doable. It's doable. Yep, it's doable. This is wire wrap wire. This is 30 gauge solid core wire with a very, very weak jacket around it. You can strip the jacket with your fingertips. The reason it's used for wire wrapping is when you wrap this wire around a square post, at the interface between the round wire and the square post, it'll push in that corner a little bit and make a cold weld, which makes a very good electrical contact. Interestingly enough, in Vietnam, the field radios were very, very dense electronics. And the reason they were able to achieve such density in electronics is that they used wire wrapping. And you go, but bother, that's what they taught me in the 1990s when I went to Radio Shack in order to build ancient 7400 series 5-volt logic. This is nonsensical. But the reason behind that is that when you wire wrap, you have a bunch of those wires that are sitting in a third dimension. And that third dimension can represent a very heavily layered PCB. So you've got like 10,000, like maybe like 30 layers of wires that you can actually lay down in order to build your PCB. And so you can make it super duper dense and also serviceable. So there's a whole thing about wire wrapping wire and the density of electronics that they were able to achieve. All right, here's my thinner solder that I just got. Good old thinner solder. I'm gonna power this thing up. And so so we want, I mean, there's a VSS, there's a VDD, and there's a VCC. What the hell does that even, what does that even mean? VSS, VDD, VCC, V common. There's our serial clock and serial data. Res number. CS, that's chip select, VBAT. I think we want VCC and VDD. So we want VCC, which is pin 15, which is all the way up here. Oh, you guys haven't seen me do a skillful soldering thing yet? You guys are in for a treat. One of my primary skills coming to this platform, I have extremely steady hands for soldering. And partially it's because of bracing my hands properly. I remember the camera lens. Yes, I've done repairs that would blow your minds. I need to actually tin that. That's not taking on solder. I got thinner solder, so I'm actually going to be better at this than normal. But yeah, what I'd like to do is actually get this thing working. So we'll see what we can accomplish here. And this thing should work on 3 volts. All right, so we pre-tin that so that it sticks a little better. And then I'm going to trim it. So I tin it and then trim it. Partially leaded. I would have liked to use unleaded solder just to show. By the way, hand positioning. Let's get a little closer so you guys can see, because it's been a little while since we've done fine soldering. Everything is in the way I position my hands. I do that in order to, I anchor my hands on stuff and my wrists are flat against the table. Your comfort is prime when you're soldering. You need to be comfortable so that your hands are steady, and you need to be able to, you know, manipulate stuff on sort of a very small scale. So I'm always looking, see how I put my fingers against the vise here and then put that right there, et cetera, et cetera, et cetera, you know? The old TNT, tin and tin. I think I'm doing this in the wrong direction. I probably should have started up and worked my way down, but I got so excited by VCC that I'm just going to do this right here. Now you guys are seeing the exact same view that I am. No. Okay, hold on. Hold on. Did this turn off? No, it's still on. Oh, come on. Yeah, it's been a while. All right, hold on. All right, there's VCC. No, I'm looking at, so when I do this stuff, you see in the upper corner there, I'm looking at my OBS feed in order to give me the view. So I am looking right here. So I am twisted aside a little bit, but that's what I'm doing. So let's get SDA and SCL in. So SD in and SCL. So SDN and SCL, that's going to be white and purple wire. White und purple. Und purple. Okay. White wire. And I'm just going to strip it like this. Bada bing. And then tin it. This wire, this solder is not in a holder, so I'm going to struggle with its positioning a little bit more. Ah, what have I done? Well, I don't think a surgeon is like bracing their hands on the patient. I don't know if it exactly equates to being a surgeon. And I guess they have like weird jamshitty, or not jamshitty, they have weird like Mayo tables and stuff like that that help them position. Another way to get a perfect tinning on a small wire is to use solder paste, because it deposits exactly enough solder to tin a surface. All right, so the pins that I want are 11 and 12. Where am I? I'm over here. So 15, 14, 13, 12, and 11, these two here. Well, I got 3 of them, but I know they're the top 2. Top 2 wires, bothers soldered. Number 1. Come down at a little bit more of an angle. Why is there's like Scotch-Brite pad sitting on my soldering iron? Now these two are right next to each other, which poses its own little fun problem. That doesn't, I don't like that. Come back. Okay, there. Hold on. With the two being right next to each other, I got to be very careful about the spacing of this stuff. These pins are like engineered to be the most aggravating. I feel like that's a short right there. Do I need to hold my breath for this? I need to get closer. Let's get closer. Ready for earthquake? Earthquake! Oh no! Oh man. Well, there goes the calibration of all my cameras. This camera just unplugged, which is a big problem because that means that all of my cameras go out of whack. Properties. Deactivate that one, reactivate it, click OK. And then we need to do a calibration on it. So I need to go to my setup, then I get micro. It's going to do its thing. There we go. See what that looks like. See, the frame rate's all weird. That's why it looks funky now. It looks like a 90s music video. Properties, go to the FPS, go to 30, click OK. And then go to properties, go to the FPS, go to highest, click OK. So it loses all of its settings, and then I can pull it through, put all the settings back in. Now we can look at what we're looking at. That still looks kind of crappy. I don't know what's up with it today. Oh, I think if I get this close, I need to back up just a little bit. We can't go all the way in. I can go partially. I need a table to lift up the subject when we go this close. There we go. Now there's still a big frame rate issue going on here. All right, let's check on the other cameras, because who knows what's wrong with them. Face cam looks okay. Spring arm, good frame rate, yep. Burn the subs we're not using, but it's there. Okay, I think everything's okay. When one camera unplugs, it'll mess up all the settings throughout all the Logitech cameras. So I have my Stream Deck programmed with all the presets in them. So when I hit that, it'll use a little bit of Node Red and a little bit of like Ninja API tool or whatever. It uses a tool that somebody made for the Stream Deck that does Logitech camera settings. And so I'm able to change focus with the Stream Deck, and I'm also able to put in my color settings and the brightness and all that. The Logitech cameras have a weird frame rate until you take the frame rate down to 30, put it back to max, and then it'll like snap it back in. So, you know, good frame rate here. I'm not leaving huge trails, but on this camera, huge trails, not a good frame rate. I can live with this though, I think. I can live with this. Close the aperture a little bit there so we have. All right, so that's our, which one is that? I don't know, I wish they would. That was data. Now we need to do clock. Clock will be a purple wire, and then ground will be a black wire. So clock will be purple. Oh yeah, we need the different view. There you go. Yeah, it's really obnoxious to have to do this to the cameras, and that's why most streamers will go and buy some kind of an abomination HD camera to do their face cam. They'll spend hundreds of dollars to, the desk cam is what you're looking at. That's this one. Hundreds and hundreds of dollars to buy like an HDR super duper point and click camera that they can use as a webcam so that they can have even passable video. But it turns out one of the most common Logitech webcams is able to create wonderful, color-rich, beautiful, high frame rate video of your face, because that's its job. The back of this thing isn't soldered. I got to make sure that that whole thing is soldered. But yet people just don't know that. So it's unfortunate that they spend all that money. I can't stand this. I can't do it. Hold on. I gotta fix the camera. It's driving me crazy. What's the model? The face cam is a C920. The desk cam is a Brio. The Brio was sent in by Wexo, and I've since then ordered a separate, like another Brio, because the one USB port on it died. The solder cracked, which there should be no excuse. That should not happen. Nobody seems to be able to solder a freaking USB plug. I don't know why. Yeah, Brio. I don't know why nobody can solder a USB plug. It's not hard to do. You just have to add heat for the right amount of time. Hold on. Yeah, it's still on. God, okay, all right. Take all these settings. Do this. Let's move it around. There we go. Okay, all right. And then I'm going to hit the setup button. I mean, most of the time when stuff goes wrong for me, it's the USB port that's exploding, right? And it just bothers me whenever they do that. The exhibit we just installed has two C920s in it. The C920 is what I use as the microscope cam. By the way, FK, you should look at Kurokesu. Here, scope. It requires a little bit of soldering to get it done, but the Kurokesu aluminum enclosures that let you use a C-mount lens on your webcams. And so the Brio on the desk, I'm actually modifying a Kurokesu, once I fix my milling machine, I'm modifying a Kurokesu enclosure so that I can have the autofocus still on, but I have an aluminum camera that has a screw mount USB plug on the back. Yeah, if you need to like either ruggedize or just shore up your camera or just make it look like an alien device. But it's a much more industrial setup for the camera, which is good. I need to not desolder the other one. Oh yeah, you can make a, well, the way this microscope is, because if you do that, the C-mount adapter, it's got such a large standoff that I have it on a Naga mount on the top deck. So it's magnet mounted onto a plate that has a miniature arbor press on the back of it as a counterweight. But that holds that thing steady on the top. And then I've got 1.5 foot of standoff right now onto the desk. So I've got plenty of space to work, but I mean, the biggest advantage is the frame rate. The frame rate, so that I'm not stabbing myself with a soldering iron. Rio is not suitable for my setup. Need HDMI sources. Ah, that sucks. Yeah, so the color settings and everything, you gotta like go into the camera settings. There's something called, actually, if you use the command procedure, I think, there's a video that a guy made about how to do the procedure and get really good video out of. See, this is still leaving trails. I don't like that. Yeah, look at that frame rate. Look at how jerky that is. That should be smoother. I don't know, something's wrong with it. I think it's just the fact that the camera unplugged and plugged back in. It's just messing with me. All right, so let's get this one soldered. Oh boy. No, I screwed it up. Oh good, we can go back on that. I'm not anchoring the, I hear a dog doing zoomies upstairs. Do I need, I think I need a little bit of flux on this actually. Hold on, we can do this, we can do this, we can do this. Just need to be careful. Ta-da. Okay, STA, SCL, and then now we need a VCC, VSS, or VDD. Okay, let's see. Is there an example circuit somewhere on this so we know what to wire? Detone, huh? Of course not. We don't get an example circuit. Detone, manufacturer of STN LCD. Actually, what we should look up is this chip. Pin connected to MCU interface, ERW, blah, 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 blah. Pin internally connected by VSS. Pin internally connected by VSS LCS. Don't tell me I need all this stuff. I really don't want to do that much. I don't want to put all that much circuitry into this. If I have to, I'm going to be really annoyed. Oh my God. Okay, that's not that's not what I'm looking for. VBRef FR should be left open. Even have that? Yeah, VBRef and FR. I don't think FR is on this thing. But it's the 1306Z. 2 capacitors there from BG, VSS ground, IREF into, what the fuck? VDD, VBAT, VSS. They're not really showing much of a test circuit, are they? On TM error, 1.5K. I don't know. Can we just get away with the 4 pins? I mean, there's a lot of like support electronics, it looks like, that I don't know how to use. What is pin 7 on the... Let's see what this is. Hold on. Pin 7. I've been going nuts trying to figure out why the manufacturer wouldn't just expose the vertical refresh FR pin on the flexible pin connector. It doesn't make any sense. Gives the ability to prevent tearing. I don't care about that right now. There is a data sheet. Let's open up the data sheet. Damn it. Oh, here it is. Adafruit datasheet. All right, fine. Blah, 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 blah. Man, this is a big datasheet. 65 pages. Oh my God. Oh. What the fuck? This is a large datasheet. Here, let me swap my screens so that you guys get a better presentation of this. This is my new thing. I've been putting the screens in the right place so that my thumbnails don't all look like this. My thumbnails have always looked like this because I'm doing like work on the computer and it's at a weird angle. So, but if I switch screens, then I'm looking like this and it's much better. Okay, examples. We're looking for examples. All the way down to the bottom. I don't give a shit about anything else. I just want to see this thing hooked up in a circuit. BS1, BS2, VSS, VBAT. What about VDD? There's VSS, VBAT, and VDD. What the hell? Voltage IRF is blah, 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 blah. Capacitors value recommended. I don't know. Figure for 8080 parallel interface. Nope. I want I2C. Charge pump. Oh, wow. Okay, so we might actually need like external stuff in order to get it to run. So it might not be as simple as just getting it on I2C. Oh my God, this thing is extensive. What is this one? This one is 8080 parallel port. I'm looking for I2C. Yeah, it looks like we need external components, and I don't want to mess with that right now. I could totally have done it though. You guys know I could have made it work. Yeah, I mean, there's always, we could just like try it and then it wouldn't work. It wouldn't do anything. And there's always the possibility that I could actually find those capacitors and get it to work. I want to see like a minimalistic implementation over I2C. It seems like what this thing can do. Well, hold your horses. Let's find our information before we determine whether or not we put the Bosch on this. We can get this to go. This is we're getting into the command logic, which is always a terrible place to be. It's a terrible day for logic. Okay, so what if I do SSD 1306 I2C? See, everybody's going to be using the pre-made modules. We're one step above that. So what they have on the other side, these are all renders. They have all of the support electronics that we don't. So this transistor there, all of these capacitors and those couple resistors, it looks like are the additional things that we need to add. So I don't know if I can do this right now, but it is something that we could try eventually. Another question is, can that just be like pulled off of the thing? Okay, here we go. What is that doing? Huh. So VCC. Yeah, see, that's like a little charge pump that they have. So that's what's making the power in order to light it up. Are the panels 1.8, not 3v3? I thought they would be. I don't know. I don't know. I mean, the panel, this panel, you know what? This might be a 1.8 volt regulator right here. 662K. Your last mistake was listing the value of the part in your data sheet. Now I know everything. What is this? No, they're 3.3 volts. And there it is. There's the fingerprint that we're going to use in our crimes. Blah, 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 blah. Let's double check. 10 pieces, 3v3, voltage regulator, XC620. This is a 662. Oh, 662K. Oh, well, there you go. So it's a 3-volt regulator. So that's giving 3 volts. So we could plug it in directly if I had... I do have all these parts. I don't think we're going to put them all together right now. I need 2 1-uffs to go there. That's not too hard. The spacing of these things is such that I don't think I'd be able to get that properly unless I really broke into some... Like if I took them off of like a motherboard or something, the really, really small decoupling caps I could find. Although 1-uff, not 0.1-uff. The 1-uffs are easy to find. 560 kilo ohm resistor off of IREF. That's another one that's annoying. Yeah, okay. There's too much electronics for me to do quickly, and we're out of time since we have a new puppy. I'll show puppy pictures again just to satiate the masses, but unfortunately there's too much external electronics that I need. I can't just wang jangle. You know, I can't just put I2C directly into this thing. So we'll save that for another day. I'm going to keep this screen because it is a smart looking screen and it's super tiny. It's much smaller. Why did I say it like that? Why did suddenly I just went Midwestern. It's much smaller than some of the other screens that I have. So we know how to use these now, and I know how to put these into keyboards and stuff. So maybe at some point I can make some kind of a weird, weird science version of an OLED screen. So actually, to be good about this, I should put a label on this thing. So here, let's take this Captain tape off, and then I'm going to print out a label and wrap it around this. I'll put it over the screen just so I don't mar up the screen. But you guys know I'm good for that kind of stuff. You guys know what I can do that. I can totally do that. I can totally do that. There's no doubt in my mind. Unfortunately, I can't show you guys how cool electronics can be today. I like doing stuff like that, but that's like a 2-stream project because I'm going to be hunting for those parts for an entire, for like 2.5 hours. And we got to get back to the actual keyboard itself. So we will get this working. All right, so what is that chip called? Denture speak. Spock here. I'd like to tell you about this new game for the Sega Dreamcast. It's called Seaman. Seaman? No, it's Seaman. Get it right. Seaman used to get real annoyed at you if you said it wrong. That's the wrong view. That's the right view. No. Which one are we looking at? Oh yeah, here we go. This would be SSD 1306. SSD 1306. On the next line, we have... Yeah, the dream... I saw a post the other day with that aesthetic. 128 by 32. With the clear plastic aesthetic. Should I write I2C on it? Probably should. They always perpetually, yeah. Always the dead batteries in those things. They were cool. I mean, wasn't there like a Godzilla game you could put onto it? All right, so that should help me find this information if I need it again. Yeah, nobody... I'm trying to remember if I ever had one, because my friend who was real into the Dreamcast, he would never, like, find one for me to play, and he was, like, the source of everything. I don't know. I don't think I trust this label to not destroy the screen. I'm going to put Captain tape on it first, and then the label. Because I don't know how sticky or residuey that label is. They're pretty good, these Brother labels, but... Go back to hand cam. Well, I do hand cam stuff. I thought they would have been a really cool, like, Tamagotchi or something like that that you could mess around with, but it used to be we'd get home from high school, or rather, a friend and I would drive over to a friend's house, and he had satellite internet at the time. And so what he would do is he would have several games downloading, several games already burnt onto CD, and then he would have several games ready to burn onto CD. And so we just go through Dreamcast games one after the other. Like, how the hell, how much does this one cost? $50? Are you kidding me? We just keep going through games. All right, so what that's gonna do, a little bit of tape that I put on it, is this will hold, well, first of all, it's gonna protect the screen. Second of all, the label on it is gonna help me find what the hell I'm looking at again. And so we'll be able to, one day, maybe soon, maybe not, who knows, if I need a little tiny OLED screen on something, which, let's be honest, is pretty freaking awesome. If I need one, I've got one right here. It just needs the accoutrement. It needs all of the additional electronics on the board in order to run it. It needs those capacitors. It needs to be able to do like a kick-up power supply with those caps and those transistors or whatever, voltage regulators and stuff like that. We were so close. It would have been nice if this was a direct interface, because that would have been really, really cool. And it would have been a nice little electronic skill show for me to find a random screen in an old glucose monitor that I had, take it over, and have it run the keyboard stuff, which we could do. I could even just desolder that one and run this one. I don't want to do that today. I only have one of these things, right? I should probably order a bushel of them, but anyway, I have a dog that I need to go. Let's show you the dog. Show you the doggy. The screen, if I got them from Alibaba, it's like $1. Yeah. This one is like $1 without all the extra stuff. This one from Amazon, which I can get in 2 days with all the extra stuff, is $8. But if I bought this one from Alibaba, it'd probably be $1 plus 2 months waiting for them to get in. So this thing is going to try to bite me when I get upstairs. So I need to pretty much accept my fate and get bit by this thing, because I need to get her tired so that she's not obnoxious towards people in the evenings. But yeah, that's what I'm going to do. I'm going to go play with the puppy. I'll play with the puppy. This is Willow. Yeah, she's got a loaf butt. She got a big corgi butt. Rah! I'm a dog. Yeah, she's very, very cute. She bounds at stuff. So I'm going to go do that, and then I'm going to be back tomorrow, and we're going to figure out this muxing and demuxing stuff that I want to do. That's where this project gets really weird, is that we've got a whole bunch of lines that we need to put power onto, and then we need a whole bunch of lines that we need to go through to see which ones have power on them in order to determine what key is pressed. And the question with that is whether or not that's going to feel slow. Is that going to feel slow? Is that going to make me miss key presses if I'm typing really fast or whatever? We need to characterize that so that I can see whether or not this is a viable project. It's got a little bit of work ahead of us. Today, we did tutorials. We learned how to get the OLED working within QMK. We got a one-button keyboard working within QMK. We didn't do anything with the LEDs, but it looks like that's going to be pretty similar to this stuff. Getting Hello World was a big deal. So now that we've got that, I need to look into the code that I need to doctor in C code, which is in the QMK files, all the files that define the keyboard. I will doctor whatever that key map is and make it scan the rows and the columns. Yeah, real programmers can use, actually, it's not even 2 buttons, if we're honest. What you do is you take phone line and you tap it. And so you tap it together like this, and that's how real programmers program. They use a virtual machine that's off-site, cloud-based, and you got to log into it, and you got to do all the @ commands, and then you can start uploading the data that you've already written in your head to that oh shit, it just crashed. Okay, the VM's restarting, I gotta wait. But anyway, so I'll catch you guys later. I don't know if there's anybody that I want to raid. I've got a lot of people sitting here. I don't know where you're all coming from, but I don't follow a lot of tech streamers because I don't want to act like them. I want to act like me. And if I do that too much, it's like with people like an AVE. You ever look at like AVE's subreddit? Everybody's trying to talk like AVE, and I can't live my life like that. So I don't follow tech streamers because I love what they do, and then I'll start talking like that. Oh, that's a really funny joke. I want to talk like that. It's bad. It's really bad. But anyway, I don't know where I'm coming from either. Yeah, me neither. I don't know where I am right now. Yeah, good talking to you, Beef Supreme, and all the rest of you, all you guys who subbed, all you guys who followed, all you guys who primes and gifts and all that stuff. You guys are very generous. We're back tomorrow. Same bat time, same bat channel. There's no bats. But, you know, I'm going to be back. I'm back on Twitch tomorrow for a similar duration. We're going to work on more projects. I'm not around Saturday. I got stuff that I got to do on Saturday. I'm not going to be around. Usually we play games on Saturday. I still want to get back to Jedi Knight 2. I want to do that playthrough. I've never played the Jedi Academy, and I want to install some mods for it because there's some genuinely funny mods that I found. But I still need to win the My Summer Car Rally. We need to get the steering wheel back in here. Yeah, a couple like months ago, I played the beginnings of JK2 Academy. Maybe, I don't know. We cheesed it. It was really great. We figured out how to cheese everything. It's basically grip floor, and everybody just falls over. But yeah, we'll get back to it. I don't have a lot of game streams. I mean, I got plenty of games to play. We'll get to it. First, we got to do work. So we're back tomorrow. We're going to do more stuff with the keyboard, and we'll get muxing work, and then we'll see how it performs. I will catch you guys then. In the meantime, here's the end card with all the social links. Bop, 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 bop. OctoJ didn't get it this time. Next stream, 19 hours, 25 minutes, and exactly 35 seconds. I will see you then. Until then, I'll be on Discord. Catch you later.